Welcome everybody. Today we're going to work with these marble gate geometries. I saw this image from Rosero yesterday and it finally clicked for me. So how this is actually meant to work. So I'm going to continue on the work we started yesterday with this sandwiched marble gate, which is very, very promising, I feel. And it's actually inverted from Rosero's design, but the mechanism is exactly the same. So I'm just trying to figure out the starting position here in Rosero's design. So let's keep on projecting this. Hope everyone is doing great. How are you, Hannes 3000?
I am great. And welcome everyone to the stream. Just wanted to say hi to you guys. Hello, Martin. How are you today?
Fantastic. Fantastic. I feel like working.
Fantastic. Feel like working.
Yes.
And you know what? I'm just going to reveal it immediately. We have a special guest in the studio today. Let's say cheers to this fella up there in the corner. Look who just broke into the studio in the middle of night and took a prime seat in the studio. Cheers, Wilson. Cheers, everyone out there.
Cheers. Yeah, Wilson were like, are you guys streaming over there?
Wait a minute, are you guys streaming? What about me? You thought you could leave me behind?
I hoped, yeah. But no luck. So, the first thing I want to figure out is the tilt of the marbles towards the vertical axle. Let me show you what I mean with that. Because this is one of the things that Rosero pointed out. It's probably 1/8 of 360. So 72 or something like that. Yeah, 22.5. That's what I meant.
Ooh, yeah.
This has to do with how the marble is being released. So this is in the closed position. And when this... I'm actually going to CAD this just so I'm... and here I also can see the tolerances. Rosero used 150, so 16 was the marble size in this case. So what will happen when this turns forward? I'm gonna make an imaginary wall here for the marble. Boom. So one tick, this turns forward 22.5 degrees. So let me do that. So it turns forward minus 22.5. And here the marble will still be held. I should actually have done the same for the... I'm going to redo that and do the same for the teeth right here. Tooth. Always a tricky one, that one.
Tooth, teeth. Same thing.
Different name. Let me... So this is mimicking the action of the gate. Minus 22.5. This is half the step. And as you can see, the marble is still securely placed between this little point of the tooth here and the wall. And if we then do this thing one more time, one more tick of the clock escapement. Let's copy this and let's revolve it over this axle. Minus 22.5. Check what happens with the wall here. The marble, this marble can now freely escape. Oh yeah, you can see it. It's in the wheel position again. So now the marble will fall down. So this makes a lot of sense. So now we're going to take what we learned from this and apply it to our own sketch over here. So I think I have to turn my sketch 22.5 degrees. Let's let's make a line to this marble. And then let's constrain it towards this vertical line. Exactly, it's 45 now. It's not happy with me. Let's see where we should start debugging this. I think maybe this line could be in the way. Or if I just use this constraint that we did have. This won't work, okay. Let's find out what seems to be the problem here.
Rabba-dabba-doo-da.
I want to rotate everything, and I don't see anything that should stop me actually. But sometimes when there's a circular pattern, Fusion is just a little cranky. I'm blaming Fusion again.
As we learn, it's always Fusion, you know. Can't be your ideas, no?
No. No. This could be the problem. This is probably the problem. If I let go of that.
Björn Valentinus thinks this looks like a rocket engine setup.
Oh, that's cool.
Yeah, he's not wrong.
So now I can rotate the pattern, which is what I needed. So that's progress. Let me make a line that I can angle this marble to. I'm going to make a construction line here, and here we go. Taking the numbers directly from row 0, 22.5. There we go. I just have to fix this wheel tooth pattern. Oh, look at that. That's interesting. That's better than what we had before. Ooh, I like this because maybe the marble entrance can be... So today we're gonna look a lot on this hockey stick here.
Woo!
Ooh. That goes to the Hannes 3000 motivation soundboard right there. And let's just go to the physical reality to see what have gone wrong here. Yeah, my revolve has gone wrong. That's not so strange. Let's take it step by step. Even that has gone wrong. Oh, it's because it's not visible. There we go. So far, so good. And my revolve pattern is dead. You can see it down here. It's yellow.
Oh, yellow. And we all know what that means. You don't eat it, at least.
No. So the rule is very simple. If you think of yellow snow, yellow sketches is like yellow snow.
Don't eat it.
Do not eat it. It's like a memory technique.
Excellent.
Advanced stuff. So we're gonna revolve this, half of this. What 59 selected? We're gonna roll half of this over this. And we're gonna cut out this nice 3D cutout from the spherical marbles. Maybe we should think a little bit. Is that a good idea?
Has it ever been a good idea to step back and take a little thinky pause?
Because I'm checking just what Rosero used. He he used how much extra space Rosero gave the marbles. 16.150. I'm gonna copy even the tolerances. Why not? We have a big sign here on the wall. What would Rosero do? So we have to follow that. So I'm going to change this measurement 40.150. Oh, 50.150. But 40.150. There we go. So then this is slightly larger than a 40 millimeter marble. So like I showed yesterday, I'm going to work with other kinds of marbles on this machine, trying out wooden marbles for better sound on the vibraphone. So we do not have to have these rubber patches, and that's why we can make them so much larger. It will look awesome.
You want to know my reaction to that? Woo!
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 Brilliant. What has happened here? So here's the ID that came on the stream yesterday. This is pretty cool. It's a sandwiched escapement. So it's a hidden escapement inside. And then we mirror the outside marble edge. And the marbles are comfy and cozy in there. And we still have a perfect escapement wheel in the middle. So that leads us to cutting the escapement pivot itself with the new knowledge from Rosero's image that we have right here.
The thing of true beauty. Woo!
I sure hope so.
And whenever you feel like taking a small pause, Martin, we have a lot of Dropbox reviews to go through.
Yes, let's actually do that. We saw that there's a lot of Dropbox suggestions, so let's crank through them right away. And we have a lot of suggestions regarding this escapement. So before moving on, let's go into it. Here we go.
And I'm sorry if they're out of order or misplaced somehow, but hopefully this will do fine.
Insert. So this is for the registrator. Insert hex nut from slot on the side. Ooh, that's a nice idea. This is a brilliant idea. Alan. Of course, it's double-sided machining operation. I was thinking how to lock the nut in there, and I didn't get the idea. This goes into the this goes into Excel.
Yeah, you got documented, Alain. Woo!
I'm just writing here. Slide nut in from side on POM registrator shear part. Fantastic suggestion. Thank you. Next suggestion.
Next one.
I can't really read. Programming wheel or drum wheel, spring-loaded detent that looks arms to disk. What is this? Indexing disk connected to the side of the drum. Aha! Now I see what it is.
Dividing head style timing between programming wheel and shaft.
Ooh, this is not bad because this saves space on this save. Gretzky's. I like this.
You like this?
I like this because you have to be able to read it. It's so this is about the musical timing between the two drums. Let me just show. So if you can minimize it to the smaller position, Hannes, see if that works today. Can we still see the suggestion there in the smaller one? Look at this.
Oh, wow.
Perfect.
It's like we're pros.
So this suggestion is about this little part sitting down here. And I have the indexing on the surface here. And this is to very accurately index these two drums, the position towards each other, between different tempos of different songs, just like we did on the original machine. And this suggestion is using a machinist technique with indexing plate, and they put the indexing here on the side as well. For accessibility, you would need to be able to put your hand in here and access the side. And depending on what sits in front, that might be an issue, that might not be an issue. This takes up some sideways space on the wheel itself. My solution, maybe that's not needed, but this is a super good weapon to keep in our arsenal. This 2 out of 2 so far goes to the Excel sheet.
Ooh.
What was it called? Indexing disk timing adjustment from side. Super suggestion.
From DNH.
DNH. Gretzky. So let's have a look at the next one.
Elder bassman. This is a cage you're looking at, I guess.
Ooh, that's also cool. So to lock the bolt in, this is a good 3D print. 3D printed part. So we talked about how to lock the nut in. It's sliding in from above. Yeah, I'm just gonna keep the sheet open because these are all good. What was the credit?
Elder bassman.
This is interesting also. Elder bassman.
There you go.
Nice one.
Okay, what happened to this image then? Let's see if we can sort this out.
We have posted new suggestions for image format, so we can go through this more quickly on the stream. And so we're gonna ask for 1920 times 1080, like full HD images.
Yep.
And if you can keep them that, this will go faster for everyone. It will be amazing. Alternative gear proposal for MM3 with explanation. Crank clockwise. Wheel is clockwise, so there should be like the one. So this is probably smart. This is a little outside today's stream topic. Can you put this, Hannes, in an gear train folder and we revisit it?
Okay. I will do my best.
Yep. Let's take the next one. The registrator looks like a piston in an engine. For sake of maintenance and ease, you could apply the same geometry. Can be bolted on and off. Oh. This is also interesting because when you slide all 40 into the shaft, probably it should not. This is a good point. So this is about the registrator that we're going to work on later to be able to have it assemblable and disassemblable. Okay, cool idea. Compact, old system, new system. Okay, we have so many suggestions, so we should actually start to sort them into genres, so we can look at the suggestions related to the stream. So let's save this one as well, and let's go for the escapement related ones. Yeah, let's save this one as well. Let's save this one. Okay, they've turned the thing around, so the bolt is on the other side. Interesting one. I do not really understand exactly how it would work, but I like that the bolt is centered in this case. Okay, next one. Martin mentioned the idea of a cage to capture a screw, but he didn't pursue it. Here's a way to do it. Eliminate some parts and difficulty of assembly. Yeah, that's the same image as before. Drill across registrator to weaken POM for emergency brake. Yeah, so we did that, and the drill here, the shear is in another direction, but nice idea from Crisp. So here we comes to the My suggestion is to use the marble pockets as escapement teeth. This anchor is designed to work with this escapement size. So we talked about, from Ricardo, this was my first idea. And in the stream, anyway, people said that the marble pockets... I also have the feeling this would work. We just didn't figure it out yesterday. Maybe the thing is that you have to put the escapement on the outside, because in the middle there's no material, because there's the marbles. So I think what rules this out is that the escapement has to go off center, and I like to keep everything center, and that's why I prefer the sandwich that we're working on right now. Ooh, beautiful. Because it's similar. No matter. Make sure the marble is dropped when the register is dropped. Improves precision. In MMX noticing that the marbles were released when the gate is lifted. This introduced a lot of because lifting takes time, but fall is instantaneous. Make sure that the marble is dropped when the register is dropped. So maybe this is the old... So let's go to the smaller view. If I understand the suggestion correctly, it's about the old discussion about dropping the marble directly from the escapement wheel. I think that's what's meant here. And I have the feeling that a long lever arm down here that will move much faster will lead to a much more accurate timing. So this wheel is not moving fast, which means that think of the marble falling over this edge, and I'm pulling the plate away slowly. It will come down to vibration and stuff when the marbles itself decide to fall down. If I pull it fast, the timing will become better. And that's why I prefer to have this extra step below something that pulls it fast. Let me know if I understood it correctly. Yeah, check the next one.
Here's from Rosero.
2 escapement wheels on the side. You can have one for primary engagement and one for secondary engagement, which complicates the machine in part count, but may simplify the design process, or at least allow for more design freedom in pivot placement. Ooh, here comes the argument for the inverted sandwich that I just deleted. So this is a great extra thing if it turns out that I want to pivot somewhere else, because as we will see right after this, the pivot placement is very restricted. Nice one, Rosero. Next one. Yeah, this looks like some idea that I would maybe have. And I think we should go with the classic escapement geometry just to be safe. Like, do what's tried and tested. And so round escapement teeth. Okay. Yeah, this is a good one. So this is also the middle idea. So if we need to this actually looks really good. You can still have the walls. And yeah. So this is I think this comes down to machining. This comes down to part reduction. So this comes down to that we could have. So the trade-off here is either we want to remove 2 parts and just have 1 part, but then we have the same geometry doing 2 jobs. Or we can have 3 parts, which goes together pretty easily, and they can be optimized for holding the marbles, and they can be optimized for the escapement function.
Casper Lourshade just mentioned there, more separate parts are more points of failure and more chances for timing to be off.
Yes. On the other hand, if we go to the small view, these 3 discs will be bolted together. But you're right, that's 4 extra bolts. That's 4 extra bolts. It's a nice... Whoever sent this one, it looks almost...
Shieldy freak.
Yeah. I can probably replicate it, but if you can send the step file, that would be awesome. It's a good visualization of probably how a combined thing should be done. On the other hand, yeah. Oh, this is beautiful as well.
The Moen?
Oh, the Moen is back.
Yeah.
Avengers.
No, Avengineers assemble.
Avengineers assemble. The Moen is back. Nice to see you here, the Moen. Beautiful escapement on the outside. Yeah, I mean, there's a lot of good solutions, I think, to this. And then we're back on this one. So we're gonna save this. This relates to today's stream. Ideas: 2 ways to keep the same movement for the escapement gate arms with the new rotation direction of the programming wheel. I don't know if it would really work. Yeah, another pivot there. Okay. Whoa.
Here's something intense.
Wow. Okay. Cool stuff. Not related to this stream, but this looks amazing. Some kind of showing how it's done in Excel. Amazing, from Evan McCarthy. Calculate.
MM3 System Flow Design Sheet.
Wow.
Is the title of it.
Gretzky's skating where the puck is going. This is a little bit for later in the stream. We can return to this, and this is also for another stream. And I saw this, I found these CAD files, but the problem is that we want 200 teeth and 25 teeth, and I haven't found that online. So yeah, the next one.
That's the last one.
Thank you for great suggestions. So I'm going to CAD escapement for this solution right now. I
just want to add that we also had 5 Fusion files here also.
Yeah, we're going to categorize them before the next stream. I'm going to sort them before the stream, so we only bring up the suggestions that are related to the topic of the stream. So let's look at the CAD files in the next stream. So we can prepare that before the stream, and that will be more efficient for all of you. To get it into my head, I'm going to make the escapement for this current design, and then we can think about like either having the 3 parts or having the mixed thing would make sense. The one part is like very exciting. On the other hand, there is something about how the marbles are being held here. That the marbles are being held more securely, a little higher up on the side of the marbles, that I really love. Gretzky's stick.
the Gretzky stick.
Let's keep working in the master sketch right here. So what have we learned? We have learned that if we're going to use this tooth for the escapement, this needs to be, the pivot point needs to be perpendicular. So if I draw this line here, it's not yet perpendicular. and then we make it perpendicular with a perpendicular constraint, like so. And if I slide this line back and forth, then we need to find another tooth. So let's try this one. And we need to see where these two perpendicular lines cross. And that's exactly where we need to have the pivot point, if I'm thinking correctly. Oh, sorry. I didn't mean
the greatest autoplay in history.
Yeah, so you can see that in the third image down there, the lines are crossing in through the middle of the pivot point. So let's say that you are 4 millimeters away from you. 5 perhaps even. No, 4 is fine. You are also 4. And then our pivot point is given to us from God, i.e. row 0.
The one true.
The fangirling I'm doing over row 0 is
cute.
Okay, good.
Yes.
Good. I just wanted to check.
I will tell you when it starts to become creepily.
Okay, good. I'm trying too hard.
What?
What? I want to now get this pivot point on that pivot point without breaking these things. And this is why I hate circular patterns. Wait.
You hate them as well. What patterns do you like, my friend?
Wait. The patterns water does in sand, I like. Turns out I was the one doing wrong again. Now I should be able to ask the center of the hockey stick to be right there. Come on, you can do it. Fail to solve. Oh, it's this height thing over here. No, it's this height thing. So remove constraints until you see that you can freely move things around. And now we should be good to go with this. Yes, here we go.
And cookie crumbs. You should put a bit of hockey tape on the stick to make it more silent. And for cosmetic reasons, of course.
Good idea. So let's go to the original. How many teeth are Rosero skipping? So there's 2 teeth skipped. And if I look at my design, I think I've done the same here. Oh, wait. I have to turn. This is not the way to do it. I have to offset this with 1/16 of 360 degrees because the thing is going to tick 1/16 revolution.
Tick, tick, boom.
When the clock says tick. So this is actually wrong. So let me copy this edge. Let me paste it and let me rotate. So you see what I'm doing here. I'm rotating this like this, but I'm going to tell to rotate 360 divided on 16. And then you can see how it ends up exactly in the middle, in between. So this line here, I'm just going to constrain it as well.
Let's see if there's some Gretzkys in the chat there. We have David E saying, Martin, your calculations for the pivot point are wrong.
Yeah.
In Rosero's, the wheel turned 1/16 of a turn between the 2 images.
Gretzky
in the chat, David E.
It feels, Hannes, that you are letting me like come finding things out before you're reading it out from chat to give me a little...
I saw it exactly when you were doing it. And I
Okay.
want to point it out that chat saw it as well. Okay? The Gretzky's out there.
Yeah. So Gretzky, you were on point. We have to go from this one. This will give us a completely different pivot point position. So let's redo this exercise from 16th revolution. Boom. Thank you, chat, for putting me into the correct direction. Honestly, now when I'm working only in CAD, this whole interaction is not theater. It's like it wasn't theater before, but it was very hard for me to act on good suggestions from the audience when I had a physical machine almost completed. Now I can do like whatever. If you tell me to just use a MIDI keyboard to make music instead, I can do that. Like I can actually act on good suggestions. That feels kind of cool.
Our boy has grown.
Are you talking about Wilson?
About you.
Oh.
But speaking of Wilson, I just want to say hi to our new guest in the studio. Cheers up there, Wilson. Thanks for keeping an eye out.
Cheers. We're going to print a little coffee cup for you, Wilson, so you can drink with us, hydrate with us.
Yeah, it seems so wrong that you're just hanging out there with no coffee or water.
Now we have a much closer pivot point. And this is where Rosero's point with a double-sided escapement could give us a lot of freedom. So this exact issue we're looking at right now was the reason why I redesigned Rosero's gate, and was the reason why things went wrong. So here's Rosero's gate. I'm gonna open mine. So this dropper has a completely other pivot point. It's somewhere far up because I wanted fast arm movement. Or the pivot point was already set. So for me, it didn't really work to just translate Rosero's design straight into the Marble Machine X because I didn't have that movement. I couldn't just whack this onto the machine and make it work immediately. So in order to be able to move this pivot point, I opened the gate and I made this broken escapement gate that worked almost. And here, as you can see, now the pivot point is exactly here. Maybe it's good, maybe it's bad. We'll find out. But if we want to have it somewhere else, then we could go back to the sandwich design with having two escapement wheels on the side and just a marble wheel in the middle. More parts, though. Hockey stick is there. And now we should be able to make our escapement. The sketch is starting to feel a little crowded. I'm going to abandon the master sketch and make
Abandon all hope. But speaking of hope, totally ridiculous. Just want to say good luck to us. And there's some people here talking about that the pivot point seems a bit too close to the wheel.
Exactly. That's the whole thing.
Move upper engagement to next tooth.
Good idea.
Move upper tooth.
Good idea. Let's move up a tooth. Skating where the puck is going. Avengineers assemble. Let's do that. Move up a tooth will be a much better idea. So let's move it 22.5. Why wasn't an even number here? Annoying. It's blue. Let's make it black. Let's turn some unused stuff into not you, but you. So we're gonna disconnect this one here. And we're gonna disconnect this distance. I'm gonna see if it allows me to do this. So far, so good. Now it's still close, but we want the perpendicular constraint. And the pivot point will shoot off into the distance. Error solving this. Why?
I'm just sitting here hoping that we will see an extrude. No, the offset command, right? The Mary command.
You miss it.
Yeah. I want to hear the church bells ringing.
So that I should have maybe saved it. Look at the difference that made. This doesn't seem really good. I'm gonna see how long this is. Yeah, we're not gonna have 200 millimeters long things here. I don't think that's good. We want to keep it more compact. So this is how far it turned out when we moved one teeth. Also, the dropping direction, it's too far away from the dropping direction right now. So, yeah, I'm happy we investigated it, but it doesn't feel like it's functional. This is exactly Rosero's suggestion. If we do two sides, we will be more free in the placement. I'm going to revert to this placement. Here we go. Because now we will have a very compact solution, and that's good in a way. So now let's move to the new sketch of the Gretzky stick. I just want to have a little cleaner sketch. It became a little ridiculous. I'm going to project this. I'm going to project this and this. And I'm also going to project this and this. And that's basically everything we want. Let's isolate this sketch. And now let's make an escapement. Tangential. Boom. Why are you laughing?
The boom.
Okay.
And Marcel Piensip, remember 5 millimeters is not clearance.
Yeah, good. Thank you, Marcel. You're absolutely right. So 2 millimeters this way. I'm just gonna put an angle in here for fun. 125. Let's do an angle in here as well for fun. 125. And let's let's make this tangential towards this.
New hashtag emerges. Hashtag team 9 marbles.
9 marbles.
Use 9 balls instead of 8.
What's the reason behind it?
Probably to get more space, right? Make wheel bigger with 9 marbles and skip 2 teeth.
Okay, that's interesting. That's super interesting. If it works, probably works. The thing that happens, Rosero's like justification for 8 marbles was to have a really secure release of the release marble. So what happens when you do more marbles is that the marbles are being less secure. The angle of each clock tick is reduced, but of course not by that much. So, I mean, maybe let's make this. This looks more like I know what I'm doing. So it's not the first thing it's not the first thing you want to make, I feel.
Mr. Bido, number of marbles is not critical, just change the diameter.
Yeah, so that's not true. If you think of that you have 200 marbles, the wheel will only move like a small little tick, and that will not make a secure. First the marble is held, then it's released. We want a big rotational movement to go from held to released in a very clear way. Probably 9 marbles is still okay, but it does make things worse. I'm just going to turn these black. So this is still not black. Let me find out why. I can't move it anywhere. So we have a new rule, and it's the industry standard rule, never leave anything unconstrained. And I can't figure out why this line is not constrained.
Rosero chiming in also. 8 was still a bit arbitrary, but with 9 or 10, it shouldn't make a big difference indeed, and may make a pivot point more ideal.
Okay, cool. Now I completely changed my mind.
Yeah, what would Rosero do?
So let's definitely investigate that. Let me just finish the 8. And probably I'm going to leave these designs up so we can compare them all later. So, of course, oh yeah, I forgot the angle. So this is the, no, yeah, now I know how to do this. Now we have to decide, so this is in the engaged position for both of them, or I made a mistake. No, this is correct. So this is the angle. This is not how the escapement, we have to rotate one of them. So we have to set an rotating angle. So I'm gonna leave this one engaged, and I'm gonna rotate this some amount of degrees. So we're gonna copy this and rotate it backwards like this. And now until it disengages, and some round nice number. Should we do -10?
Oh, let's do. Please do.
You like 10?
Oh, yes.
that will give... let's just do 10. Because Hannes got so happy. And then we're turning this into construction lines. So with 10, we have a clearance between the tooth of 5 millimeters. And I know I've said that 5 millimeters is not a clearance, but it depends a little bit on how big the part is, I guess.
Kuja Filth YT. Anyone else think that this marble machine is kind of a Lovecraftian experience where thousands and thousands of people gather, hypnotized by an artifact, a vision, drowning us into madness?
I think it's a reference to H.P. Lovecraft,
Yep.
the author. Maybe you, Nerd King of Nerd Kings, can tell me the reference.
Mountain of Madness.
I have it right here on the t-shirt. Once I was asked to make the music for a Cthulhu musical.
Oh, whoa!
At Dramaten in Stockholm, Sweden's largest theater stage.
Now that would be something.
So they were doing... And then later I saw the South Park episode with Cthulhu.
Yeah.
And I was like regretting that I didn't do it.
A Martin Molin composed Cthulhu musical. Now that's something. That's something.
So
a lot of people losing their marbles in those stories.
So...
And the Meditron sending some positivity our way here. I have been mesmerized since the first video and everything since. Thanks for keeping the dream alive. Love from Seattle.
Wow, thank you
so much, the Meditron. The Meditron. Cool transformer.
I can honestly say that I feel more in balance with the project than I've ever done. It's all been like a whirlwind from the first bandsaw plywood cut gear in Backaplan, and I've been in this whirlwind, and now I'm like above taming the whirlwind. Like, I don't even know how it's done, but it feels like we're doing it.
Screaming at the wind.
That's not what I said, right? Right, Wilson?
Right, Wilson, do you agree? Of course I agree, Martin.
Oh, that's the first time. Maybe Hannes Wilson is more lenient.
I agree with everything.
Meanwhile, it's taken me 100 years to constrain these blue lines. Where can I get some kind of grip? Let me first make this distance. This is not my strongest suit. We need to maybe tie it to horizontal line, vertical line, I mean. There we have our first black line. That's a good sign. So maybe the length of this. Okay, okay, there we got some more black lines.
Yes.
That's a good thing.
That's what we're all here for.
So maybe this angle will seal the deal. There we go. All black lines. It's not a nice constraint, but we have our little escapement thingy. Let's extrude this and then look at it in like 3D.
David Allen just went back and reviewed. Martin should have also moved the bottom pivot point line along a tooth.
Oh, you mean when we skipped more teeth?
Perhaps.
Okay, you know what? We should... then... No, wait, what?
Wait, what?
Can you explain like exactly what you meant? Can you specify? Because it's interesting what you just said, Alan. By the way, chat. I think we have 60 seconds slow mode. Maybe that's too negative for these awesome Gretzkys. Should we lower it to like 20?
You know what? I'll see what I can do.
Let's try.
Where do I do that then?
On your computer.
Thank you.
Okay. There's something about these escapements that is escaping me. So clearly this line needs to not be a construction line. I did that mistake yesterday. Okay.
David Allen said, you moved the top pivot point line up one tooth, but you did not move the bottom.
Yeah, but if I would have done that, Oh, yeah, you're right. We can just... That was how you meant. We can just have it turning around. Actually, it wouldn't move the pivot point further away, though. But, I mean, look at this. It's not that bad, is it? We have to first see if this pivot point is an issue. Because now the lengths are... This is like 4 centimeters. The length feels great here. The scale feels great here. And I'm not sure yet that we have an issue. And I think I have CAD'd a correct escapement finally.
Ooh! CADing your escape.
Let's put outsides here. So we would, of course, make sure that there's clearance between these and the escape thingy. Okay, so let's look at the dropping geometry now. So let's go to this sketch again.
Rosero chiming in again. Moving the pivot the other way around counterclockwise could be advantageous, though. It makes the marble release action at the bottom more horizontal.
Yep.
As long as the pallet doesn't interfere with the top marble.
Can you read that again?
The whole thing?
Yeah.
Moving the pivot other way around counterclockwise could be advantageous, though. It makes the marble release action at the bottom more horizontal, as long as the pallet doesn't interfere with the top marble.
But if we move it counterclockwise, it's not going to be with the top marble at all. So that's why I was confused. But let's let's say we have a marble. So another thing, the closer we put the release marble, like if we could put it here, the faster we can repeat. It's not a big difference, but a little bit. So
Rosero, I mean the marbles at the top, but indeed the last marble in the queue.
Okay. Yeah.
But instead the last marble. Okay.
So let's CAD the release thing. So the
official name now? Release thingy?
What is it called? The blade of the hockey stick.
Oh yeah.
Speaking in terms Hannes understands.
Yeah, you need to simplify for me.
So here, since the pivot is here, the blade will release downwards in this direction. But then, I'm not sure that's an actual issue. Maybe if the whatever is holding the marble ends right here, it is an issue. But I think if whatever holds the marble in its lane is going all the way down, I don't think it's a no-go.
It's a no goal with that stick, right?
So let's hide the master sketch just so we can see things a little more clearly. So all this is actually to then soon find out how we can translate the movement from this registrator into this marble gate. So I'm not going to stay too long here on the release at this moment, but it does point out how much, like this pivot point placement, how much is depending on this placement. So what I like with a longer arm, let's see how long this is. This is almost 200 centimeters. Yeah, that takes some space.
200 centimeters?
Sorry, millimeters.
Oh, okay. I was like, oh, it's almost a regular hockey stick now.
It's the leverage, the speed. It will, just like a gear, it will move away fast. So when we have it very short, it's the same example before. That's why I'm not dropping marbles from the escapement wheel directly onto the instruments, because if we go slow over the edge, the marble can slip through. If I just remove this, the marble will start to fall more accurately. It would be cool to release them directly from the wheel. Everyone wanted that always. But I actually don't see this hockey stick design as something problematic at all. Although this 200 centimeter height use is a little bit annoying.
Rosero is back here. A dropping marble can now put a rotating force on the release. A horizontal release is more stable in that way. Not sure how big the difference is, but there is a difference.
Can you read that again?
A dropping marble can now put a rotating force on the release. A horizontal release is more stable in that way. Not sure how big difference it is, but there is a difference.
Oh, now I get it. Root zero means the leverage because of this sideways distance here. And if we had just like these needs to be perpendicular to hold the force, if we had the pivot point here, the weight of this marble does not want to rotate this circle. If I put it here, you can see how the weight of this marble is weighing down this circle on the right side here. Now I see what you mean. So we need a spring anyway to close this, and the spring will hold the marble, definitely. But now I understand what you meant. So let's leave it at this for now. I mean, it would be so cool to drop it from here, but no. You saw that Marble Machine X was pretty tight. Let's keep some of the basic fundamentals of what we have prototyped for 200 years already. And having this extra step, I think, is very, very good. Just letting the escapement thing do the sorting, the gating, and the step do the letting go. So let's head back. Now let's stay here. Well, actually, let's head back. I'm curious about let me have a look at Rosero's marble queue here. How is this actually done? So if I'm projecting, if I'm just projecting this, I'm curious to where the angle of the queue coming in, if there's some method in this or not.
I want to read some suggestions from Mr. Bido also. You should only hold the marble by a portion of its diameter so that release is almost instantaneous rather than from the bottom and having to move the gate X millimeters. You can also make the release a linkage so the movement to release is 100% horizontal rather than on the lever arm going at an angle away.
Good suggestions. This is crazy, but what's intended, I completely agree. Why is this moving around?
Rosero yet again here. The speed and control of the hockey stick is more reliable in quote-unquote tightness of the music. The marble wheel has more mass to rotate and is therefore more unpredictable and sluggish.
Yep. Good with some confirmation on that. So what was the name of the previous Gretzky?
The previous Gretzky, we have Mr. Bido.
Why? Oh, I constrained this. That's why. This also is 230. I'm just gonna say that this corner. So this is a little bit what Mr. Bido meant, and I wholeheartedly agree. If we can get a very repeatable position here, the marbles will be released more repeatable, and it will be less dependent on on musical speed and stuff. So something like that. You know what? Let me just make this line horizontal. Okay, great. Now I'm gonna check this angle. If there's a method in this madness right here. There is a method, 70 degrees. What would Rosero do? Let's do 70 degrees. Probably like 70 degrees was in that. I don't know. Rosero, why 70? Was that arbitrary or was it just some like known fact that made you pick 70? So this is what worries me, that we have a pivot that I want to put here, but we have a marble queue that I also want to put there. It's funny because I don't even know if we can have 40 millimeter marbles, but it's just a dream.
And now is the time for dreaming, everybody.
I would much rather have it steeper like this.
Mm-hmm.
The marble queue. I would actually want it like... Let's put a few more marbles in. To get out of the way for this pivot.
Mr. Bido again here. The idea in my head is like a coin slot with the tube for the marble and just a little dimple penetrating the path, the same way a padlock bolt locks.
Yes.
Mm-hmm. Brill, Gretzky.
Yes, that feels very good. I think the way to hold these marbles will be, and I know this is going to make some people nervous, will be acrylic tubes.
Mm-hmm.
And I think if we have them bent on template and machined on a CNC machine like ends, and the cutout over the gears is CNC'd away from the acrylic, so there's no manual work, I think we can make repeatable acrylic tubes that will hold the marbles perfectly. So one of the biggest issues with this design was the accuracy of the placement of these. Jesus, wow, how I was fighting with this. I thought I was an engineer.
Yeah.
I was only a fan engineer.
I've seen some actual footage of you taking the fight against those.
Yeah. Yeah, it was actually, you can see me here. This was actually real time acrylic. I got 2 punches in, and then it was over.
Rosero chiming in here with the angle.
Yep.
So that angle is arbitrary,
Woohoo!
kind of. I wanted to have the gear not yet protruding into the marble queue to have the full force of the queue on the escapement.
So perhaps I can get away with a little bit of a higher angle. So nice to have live feedback. It's amazing. So now, when we see that queue in the background, we're going to connect this movement. So a connecting point over here. And we are somehow going to make this flip forward. So we're going to push this forward. So let's say we do that here.
Rosero, that should be a t-shirt. Fangineer.
No, what am I doing? So that's 10 centimeter above. And basically, this looks like it's working. So I'm linking from here to here. And yeah, that would work, I guess. We need a spring somewhere. We could, for example, have a spring here. Let me hide this sketch so it looks a little bit less awful. So I'm just pushing these out. So we could have a spring. So the cool thing now is that compared to the first machine, the marbles were... where is my image? This is not working, okay. This is working. Okay, we have something going on here. Sorry, I can't show that. The marbles are not crossing the mechanics. That's the whole greatness of this. Mm-hmm. All the mechanics are under the marbles. The marbles are never passing any of the mechanics. So here's the spring. Pulling everything back into its position. And I'm not actually really happy that we do have to push with this direction of the programming wheel. I think pulling feels much more stable. But this is actually a plan. This could be a plan. So now I would like to find out how much travel, how much we need to push this to the right to close this 10 degrees. So then I'm just going to make a line.
Rosero with one last greeting here. Going to do something work related now to be able to justify my salary. Good luck, looking good, I believe.
Thank you, Rosero. Your Gretzky salary have been justified. Which is love and air. Thank you. Good luck with your workday today. I hope to be able to show you something logical when you're back next time. Now we're going to find out the travel. And I think Gonzonator asked yesterday, is this going to move less than the first machine? And I kind of think it maybe will. It's kind of cool to have a mechanism that moves like just a little bit. It feels like energy efficient. So here is the final verdict. Right now, we need 17 millimeters of movement between the two positions. So I think we had like something similar on the first machine, or 2 centimeters or something. So if we would just rotate this whole thing, if we would rotate the escapement, if we would have the same pivot point and rotate it under, so counterclockwise, what difference would that make? Yeah. So basically, we're soon coming up against. Yeah, I know what to do next. So we're soon coming up against where like the instrument positions need to inform us about like optimal pivot points and stuff. There's no way of digging down too hard there, but I want to discuss how we can mute this, because we need to break this link when muting. The muting mechanism on the Machine X was flawless.
Okay, so what can we take from that design?
Yeah, the problem is that now when we're pushing in the other direction, so let me sketch something here on the iPad, the sketch pad.
The sketch pad.
I should call it.
Yeah.
Here we go. Registrator. Here's the programming wheel. And when the programming pins were coming like this, we were pulling here, and we had the really nice. We had this design, and it was awesome. So what we did is that we lowered this to break this connection right there. And I've been thinking if we could do the same, but in the opposite direction. So here's the programming pin coming in like this. And here's our link. And so very, very basic. This is the next link. So it's pushing on that link. And if we lower this, so let me give another good one. We lower it here. When this thing comes pushing, it will push on top. I should have another color. But as I said, I'm not happy about the pushing. This is my idea.
Mm-hmm.
What do you think, Hannes 3000? We could also.
So it's reminiscent of the MMX though.
Yeah, it is. We could also hire it, because what will activate this, I think, will be a Bowden cable. So we have this pull. This is an industrial solution. So you have these push-pull levers that are sold in a variety of formats that is connected to a Bowden cable. Bowden cable.
Bowden cable.
So, which means that you can push this back and forth, and you can translate a mechanical movement of the end point of this thing here up and down, like wherever in the machine. So that's exactly like a handbrake on a bike, or a throttle like on a tractor, or a throttle on a lot of industrial machines. So,
Mr. Bido, you should make the horizontal one length and pull it away.
can you repeat that?
You should make the horizontal one length and pull it away. Make it like a cam, Jeremy Heidi. Akash gown car. Why not convert the pushing to a pulling motion around the pivot?
Yes, I want to exclude pivots if we don't need it. But wait, did I hear something amazing? No, wait, that means half hits maybe.
Mr. Bido also. Retractable programming pin, question mark?
Oh, that sounds like Very complicated. Okay, imagine if you put a Bowden cable, if this was what I heard. If you put a Bowden cable, if you put a Bowden cable in here, and then you just retract this surface here back into itself, then there will be no lifting. There's one issue with this. We have to think about half hits. And this is why the other idea, this is why the Marble Machine X was so fantastic. I could mute and unmute regardless of where the programming pins were. So, I love this idea. No, we need one for every. That's actually kind of complicated. Never mind. The retracting horizontal, can you read that one again? I didn't quite get it.
Yeah, not me either. Let's see here, Mr. Bido. You should make the horizontal one length and pull it away.
Yeah, maybe Bido was into the same idea I was here now. The good thing is that if we lift it up, like in the turquoise thing here, we can connect like a lot of channels together. So I can have one muting lever for the whole vibraphone if we want. We can group them pretty easily, like we did on the Marble Machine. To pull them away, I think there will be one Bowden cable per channel, which I think maybe is a little too many. There's also another problem, is that if this Bowden cable sits here, it will the Bowden cable itself will travel with the thing when it's skipped to the right.
Miege 90, just use a pivot to change the push to a pull. Kuki, rotate the location of the pins triggering clockwise so they can pull down.
Rotate
the location of the pins triggering clockwise so they can pull down. Is that the retractable pin again?
No, I think this is something, I think, if I understand it correctly, if we go to CAD, I think it's about putting the registrator here. So reading here, but the problem is if we pull down. Oh, can we pull the stick here?
James Pryor, yes, push to pull and use old solution.
With extra pivot?
Yeah.
Is it team pivot?
I guess because we know that works, right?
Yeah, the old solution was awesome.
Flawless.
It was flawless, actually. I just don't like the extra pivot.
Wayne Euroda can change push to pull without a pivot. Then you need to explain that, Wayne. No extra pivot needed. Mm-hmm.
Yeah, the other thing is that you can just extend this already here. That's a lot of people have sketched that. And do everything up here. Then you already changed the... That's maybe... Well, but that's very high. We can also still revert. Like, we can still make one helical gear set and just revert the direction of the programming wheel. So...
Hashtag team push.
The other idea is to go... That's why it's so fun now. It's also daunting that everything is open for discussion. But what we also can do, if we look at the gear sketch, is that instead of using... then we don't have the nice indexing solution that I love so much. Then we have to have the same indexing as we had before. But my point is that we can use this. Oh wait, we have that belt somewhere. So instead of this belt,
Christoph used the design of MMX with minor adaptations. You already know this would work.
yeah, with this muting mechanism, I'm very inclined to agree. Look, this is my idea. Oh wait, but then we don't need a belt. So we just use this in between gear as we always did. Or we use a double side, because you can revert the motion if you have a double-sided timing belt. And since this belt is since this belt is so slow, I'm not scared of the noise. That means another kind of belt. Let me actually go and try to find that. Oh, something happened with my images. Oh, I moved them. I moved them before the stream, so my OBS is not finding my stills. I have to relocate them. Can you pull up a double...
Just wanna quick here.
Yeah.
This is what Wayne Uroda was talking about without an extra pivot.
Wait.
Quick sketch.
Wait. This looks very nice. Oh, don't take it away.
I didn't mean to.
So this would just mean that you just drop it. This is basically exact. Let's think of half hits. Yeah, this is the same thing. Because up, I was worried about. Okay, let me count this. This was a brilliant little sketch. Thank you, Wayne. Is it Batman?
Of course, it's Batman.
Can you leave it open?
Okay, you want it.
You
you can have it.
Open. So what I've been worried about is things moving around in ways we don't want them to. But this simple sketch just like showed me how easy it would be to make sure things did not move around. We're gonna do this. I'm gonna do this. Because my point is, when you push something, it wanna push itself to the side. When you pull something, it just wanna pull straight. That's the benefit of the pulling. It just feels more stable. So why didn't I make it horizontal? That's a good question.
Chat is also singing on that now.
So here's my point. Where's my point? Let's pretend these... No, let's not pretend. Let's just do them. These blocks are like stop blocks. They are just like still, and they are constraining the motion. So this thing in the middle can just slide back and forth. Will that work over here, or will we need another link? We probably need another link. Never mind. Right now. And this thing has a stop block right here, which is also stuck. So it can't push itself upwards. But underneath, just like on the original normal machine, here is the muting mechanism. And here is the Bowden cable coming. And it can go up and down here. So it's a little piston, something that it runs on. And then I'm going to simulate the cable coming from wherever in the machine, like this. Which means that this one can drop down, disconnecting this connection here. And we basically have exactly what we had, but in the pushing direction. Sweet.
Sweetness.
I still don't like the pushing, but I think it's not an issue anywhere. So now to the thing with this pivot point. Do we need another pivot? I think the answer is yes. Obviously because of the angle. So we need this to be another little connection right here. This is so much fun, Hannes.
This is amazing.
This is so much fun.
And thank you so much, Wayne Uroda, for that little tip right there.
Yes, this is some concepts are hard to explain as simply as that sketch Wayne just sent, but it's a cool challenge to try to deliver an idea that simply. I mean, I'm super wordy. I talk all the time. And if you listen to the Bruce Springsteen autobiography, it says, we don't tell people that we're great, we show people. That's why it's called show business.
Ooh.
And so whenever you can show an idea and not tell the idea is going to come through much clearer. I like the fact that the Bowden cable system is hidden here because we have all this space up here for marble handling and the mechanics is just being taken care of down here.
Hiding in plain sight.
Hiding in plain sight. This is absolutely viable. And we have the same chance of oh, no. Here's the first problem. When this comes forward, when a programming thing is hit, and I at the same time unmute here, this will fly up into this ceiling and it will jam. So I can't unmute while a programming pin is playing. That's why this has to pivot upwards in those circumstances. And this is where I am getting nervous about the pushing. When we're pulling, it doesn't want to push itself upward. If we make it heavy enough, so it's just like resting. If this is like heavy enough. Oh wait, does this mean we can exclude this?
James Pryor said here, rather than dropping the muting link, could you pull it up and then gravity helps keep it in place during play?
Yeah. I think we will have more space here to hide all the Bowden cables. I think to have them up here, they will interfere with the marbles more. And I think spontaneously, I think like putting this feels easier this way around because now we still have gravity keeping it in place during play. The thing that is a little would this want to... Yeah. No, I think this would work as well. But this, we can't constrain it in the top here. But if it's lying on its weight there, I think it should be okay.
See, another sketch just appeared in the Dropbox folder right here. Let's see what we have with this one here.
This is the same solution, right?
Same solution?
Yeah, I think so. Bowden. This is something else.
Muting with Bowden cables.
Wait, how would this work? Again, very, very good delivery on the sketches. Super clear and informative. So happy that you're engaging with this design. It's very, very helpful. I don't quite understand this one. The purple thing can go to the right. But I don't think you will be able to mute exactly when a programming pin is coming. I think it would get stuck if the red thing is going to pivot. Yeah, I think it will, in the edge cases when a programming pin comes while you're muting, I think that would bind. But I'm not sure. So if you wanted to restrict this thing from sliding from like just bulging upwards. This is what I mean when we have this pushing and things just bulge out, which they don't do when pulling. You could have a slot here, like this. It's a lot apart. And you could just have something here that links up to here, maybe somehow. That can slide back and forth, but just keeping it from bulging upwards. So we constrain that point. Maybe it doesn't even need to have a slot. Maybe it can just be like a link around a wheel. I mean this. Oh, but maybe that's a good idea. So we just constrain it on a wheel there. So basically this whole thing goes away completely. This might not be that bad. You have a little angle shift and basically this thing. Now it doesn't go away completely because it falls down when we mute here. We just need a small little thing here.
And people are still like wondering why we really do need the pushing.
Yeah, it's because the programming wheel is turning in the other direction at the moment.
It can be turned, right?
Yes. And moreover, I'm still thinking about this base placement.
Yeah.
Which would move me back to this side, which would again reverse the programming wheel direction. So then we don't have the pushing. So
bring back the pull. Bulging will happen everywhere whilst pushing. Johnny Gangster.
Yeah, Johnny Gangster, I'm with you. I don't like the bulging. I do not like the bulging.
So perhaps just revert to the stuff we know.
Yeah, so probably we should like step far back to see where I should be standing. Where is the? We had me in one of the earliest ones. We have here. Here we go. We have in the blocking design.
Yeah, Team Pool is appearing in chat here now.
Yeah. But I'm on that team, but I'm also on team trade-off. Team correct trade-off. So this was like the eureka moment when I'm standing on the other side of the machine, facing the audience. So this is the front of the machine, turning the crank towards me, which means that we have mirrored the whole rotational direction, which is perfect for the loop drum. So that's another thing to consider if we move me back.
Insert a third wheel, a third drum somewhere. A small one.
Are you referring to Wilson right now?
Yeah. It can be a third wheel for us, right?
Yeah, I think so. Because here's the... So this is... Everything is related to everything else. And that's why I'm so happy that we're doing this in CAD, because we're going to have... Just like Harry Potter, the story, everything is relating to everything else. We're going to be able to have all these million connections alive. So which means that we get a brilliant idea. We can see how it should affect all 1,000 other parts, which I couldn't on the physical model. But like the first crank rotational direction should be a big thing. And right now, I think the way to... Basically, what I wanted to do today is that I wanted to look, can we solve this? And I would say the answer is a clear yes.
Woo!
Can we solve it if we pull it? Yes. So basically, we can solve this regardless of the programming wheel direction. So this means to decide the programming wheel direction or my position, we should start to look elsewhere for information. And I just wanted to share with you the reason why I'm considering this base position again. So if we have... Can you pull up the hammer jammer on us?
The hammer jammer.
Yes. So we have figured out there is a mechanism that allows us to hit points with marbles that hits the bass strings. That the hit points have a mechanism that then hits the bass strings. So the marbles are not actually hitting the bass strings directly. And I am... So one darling that I will kill on this machine is to have several marbles hitting the same notes. So you can play like I did on the Marble Machine X. Instead, I just wanted 4 marbles for the bass guitar, so you can just play do 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 do. You can't play that fast. But with a hammer jammer and this playing direction and me standing where I am always standing here on the right, we could have more marbles per string. And the machine can become less wide, perhaps. There's something about this playing position, and the levers are also going to be more visible. Maybe not.
Here we have the hammer jammer bass prototype.
We never seen that one.
No?
I don't hear it here. So what channel is this? We have to give credit.
Big Walnut Music.
Big Walnut Music. That's so cool. Can I see it again? With some volume, perhaps?
Okay.
This is so promising, you know, because I don't think the player is like striking super hard there. And it sounds awesome.
Yeah, love it.
So, which means also we can flare out the hit points to widen them, which means we can use a normal bass, we can use any bass, and just put a good hammer jammer on it. Cool you found that video, and shout out to that YouTube channel.
Yeah, Big Walnut Music. Woo!
Woo! So, I should do this in the drum kit assembly. So let's hide this one, and let's just make a crazy sketch right here. Capture position for now. So here is my point. I'm sketching marble hit points now. And we would be able to do them like this. And I can push my arm in here to play. And I think the notes... Where's the vibraphone? Gonna go... Oh, we don't have a vibraphone here. I'm gonna update so we can see the beautiful hit points. Oh yeah, look at this, Hannes Knutsson.
I'm ready.
Wow, it appeared an escapement gate.
Ba-da-da!
How far we have? How far?
I know who's to be held responsible for that. He's sitting in the corner of the room. He's starting to shadow CAD right now.
Look at what happens when we put the bass guitar here. Are you seeing that all of a sudden we can move the drums over to the left?
Space!
Exactly. So
the most precious currency there is, space.
Exactly. Look at this. We get 200 millimeters of space. What did I move now? Something went wrong. No. Okay, the bass. What is happening?
Everything and nothing.
Minus 400. I think the bass is moving with it. Never mind. So here is the kicker. Kicker. Let's move this over. Let's move it on a picked direction along this little line. There we go.
Ooh.
Let's update this. No. I don't think it has updated the bass position, right? It's my eyes deceiving me. Oh, I'm not looking at... This doesn't look the same. Save. Oh, capture the position. Capture and save. That was the problem. Now we can update the bass. Should go to the right. The red bass should disappear as well. Component is out of date. Yes, that's what I'm trying. Here we go. Why are you showing me the red bass when I saved it with you muted? That's maybe how it works. Maybe I'm stupid. Because look at this crank we have to like pull out like there. It didn't feel good.
Yeah. Oh yeah.
And look now. Like, what is happening over here? Could there be a little hi-hat now there?
Ooh.
So my point is that the compactness of everything, it just makes more sense, right? And then we have another shelf for vibraphone on top of the bass. And the vibraphone marbles just have to jump over my hands. Like here, if I zoom in, here's my hands in here. Okay. a lot to think about, everyone. We did really good on this, so thank you so much for your sketches. You take it away, Hannes.
Well, I've learned so much already today. Such a great start to this day. With these beautiful tunes here from Martin, we're gonna take our lunch break soon here. This day, we're gonna leave the stream open this time during the break, so you can just stay here, chat away, and we will be back in an hour. Oh, look at those beautiful fingers making beautiful music. I just want to see what the amigo up in the corner is thinking. He's happy as well. Oh, wow. You know what this song should be called? It preys on noise. Oh, yes. On noise. Oh, beautiful. And I'm ruining it. Just talking all over it. Well, you know, everybody. See you after the lunch. Take care. Stay here on the stream. See you soon. Bye. Avengineers from the Marble Universe. Here we go.
I'm excited, everyone, because we are at the very foundational design decisions right here, right now. I'm gonna make a hi-hat, and I'm revolving the hi-hat as always. Like revolve command, this is very basic stuff, but for most round shape, consider to make a sketch like that, and then revolve your shape around the center axis like this. This will, this is a tool that I didn't use when I started with CAD. I just started with other ways. So that's a little tip for you. How large is a hi-hat actually? Is it 12 inches?
How high?
Large.
Oh, yeah. Chat, remind us. You already did this once.
Yeah. So what is a standard hi-hat in inches? I'm going to guess 12.
Yeah, something like that.
Oh, that's too much. Yeah, and divided by 2 because it's the radius. So when you're in millimeter, you can actually just put 12 and then quotation mark, and Fusion will convert for you.
Yeah. This is the learning channel now. You learn stuff here.
So in this morning stream, which was I was very happy with all the help from chat and great ideas. We were working on this. And we're looking at the rotation. So we did this marble gate here, and we're looking at the correct pivot points for that, and things are looking promising. But now I'm on to the question about the bass guitar placement. So it's either the green one or the red one. And right now I realized that the space question might become completely solved if we go with the green placement. Which means that I will stand on the normal side of the machine yet again. And what I want to do right now is I want to put a hi-hat in, because now I can have my drum dream. I love the band Wolfpack, which plays like funk, and very often they don't have like crash cymbals. It's often a kick drum, a snare drum, and a hi-hat. And I dream about having these 3 drums front and center on a line. And I think, look at this. Also look at this like nice.
Ooh.
There's something about this that feels right, isn't it?
Dr. Noobstein, 14 inches, not 12.
14. Thank
14.
you, Noobstein. You should change your name to Prostein.
Prostein.
There's no noob about that comment. No, it was not so funny. I tried, okay? Don't ask me.
You can't always deliver, okay?
Don't ask me, Hannes 3000.
Full-size hi-hats are 14 inches. Yep. We got it, chat. Thank you.
Awesome. We also have... I am going to tire you all to death with this, but it's something that I heard from all the Avengineers out there. is that professional engineers are taught at engineering school to constrain their sketches. Like, if all else fails, just make sure your sketches are constrained. So I'm gonna turn all these lines black.
We love to see that. That's true magic right there. Pre-satisfaction.
I think we had actually a breakdown of my parametric designs the other day, which was directly deriving from green sketch lines. And I'm applying this constraint the wrong way. Let's just do this. By the way, I was just singing, so now we have blank. I was singing the praises of revolve command. Check this out. If I want this to be a little bit better, because I have holes in them, I can just do this and make this a construction line. And if I want an M8 hole, for example, I do 4 millimeters there. And check now, we don't have a hole in the middle. But if I edit my revolve command and I just deselect this little thing and a hole appears.
Oh!
Nice, huh? So with the revolve command, you can do a lot from one and the same sketch. And that's something that I learned over the time. Few sketches is helpful in the long run. Okay, so now since we made the highest larger, we have to move it to the right. Let's move it like 370.
Let's.
Look at that. I think actually the height should be... No, I don't know. So the hit point height should actually move. Okay, we'll see. We'll see about this. Because this will lead into a very, very tricky discussion about marble drop points. And this is something that we did like the first day. I like this. I like this look. Imagine when we're filming this drum kit and it's like... And you
Sugar flak.
There's also a potential to put the symbol down here. Should we try that?
Yes, please.
How many symbols do you want? Yes.
Yes.
Let's add a symbol because, as I've been saying on the first machine, I did not start with the instrument positions. I started with everything else, and then I didn't have any place for the instruments in the end. So let's not do that mistake this time around. And thanks everyone for hanging out with us. We are hoping you're doing great. If you're at work listening to us in the background or something, just hanging out with us. We are honored to have your company. I always start with the offset plane, and this is going to be my sideways control. So, and as I said before, I don't want to offset this plane from the origin point right here. No. We have to think, what should the function of this position be? Well, I want the symbol to be to the right on the kick drum. So let's go into our browser tree and find the kick drum sideways plane. Look at this. Kick drum mid plane. I'm sorry about that. So let's offset our symbol plane from this one. So I click that one. We have selected it. And now when we look at it from the front, we're just gonna take it over to somewhere where we think it's nice. And we're just gonna make an even number. So let's put 600. And whenever I move the kick drum sideways, the symbol will move with it. So it sounds very, very obvious, but it's taken me a long time to kind of have to think about that, how to build it up.
Jesper Klang hi-hat could be overlapping the snare, right? Could give more space. Ooh.
That is a brilliant comment from another Gretzky in the chat. Yeah. Definitely possible.
Then we also had a reminder up here. Let's see. 10 produce. You should put in the dimensions of a real base you're going to use also.
Yeah. Talking about that, could chat find those dimensions?
Do you have
awesome.
What type you want, perhaps?
Yeah, like the one we were using in this sketch, I would like something like this, like a hollow body, like an Epiphone, something like this that looks like a cool music instrument.
You heard him, chat. Woo!
Which is like the largest bass you can have, which is stupid in sense. And people are complaining about the strength of the bass in those hollow body basses. So maybe it's stupid, but something like this.
In the ballpark of that Epiphone-ish bass.
And I think it's mostly two measures. Like, well, if you can submit to Dropbox like a sketch with more measurements, or if you can find a CAD model, that's cool as well. But it's mainly the length and the max width.
Yeah.
Two measurements. Like on Torman, they have those measurements. Like Torman website is like a little Wikipedia for music instruments. Let's project this little line and let's say that so we're going to go in and fight with one of the big Marble Machine dragons, which is marble drop points.
Oh.
And this is going to be very, very interesting and very daunting as well. So I'm happy we're attacking it.
But how is it you're usually saying it? The taste of revenge is burning in your mouth?
Yeah. It's the thirst that keeps me going.
Yes.
It's kind of awesome. We have air humidifier on loud volume behind us, and they are drilling in the roof. And I don't even think you are hearing that through the stream.
Yeah.
I shouldn't have pointed it out, of course. But
Now all chat are gonna listen super closely. Are they drilling? No, it's just my joints when I'm moving, okay?
Da da do 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 do. If I do this one black, we have a fully constrained ride symbol. So let's do the same with the symbol. Let's revolve our little friend. A happy little symbol.
A happy little symbol.
It's your own world. You can put it anywhere you want to. Happy little yellow symbol. Do 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 do. Like the second day, I think we streamed last week, we were doing drum positions. And I wasn't happy. I didn't find anything I liked. And now, Hannes 3000. Isn't this a good direction? Isn't this heading a good way?
Yeah, this is always how you do it. You just lay them out in the beginning, and then you like let it marinate for a while. Then you come back to it.
I think this is pretty cool. So, in this case...
They can't hear drilling, can't hear anything. Then Kieran goes 92. Is it the quiet hum of belt noise in my dreams? Because you know why.
Yeah.
It preys on noise.
It's all my still images have become delinked from my sub mix in OBS. So
well, my voice is not delinked. It's still on.
So this symbol will not be marble played. Only these three would be. And so this would only be loop played. If it can be there. We'll see. There's issues with this placement, I think. Let's save this and let's see how it looks in context. Yeah, here's the issues. The cymbal is going straight into the loop drum. So, yeah, the cymbal is a little bit of a sorrow child at the moment.
The cymbal?
Yeah.
I always love it when it's hidden, like underneath something.
Okay.
Like it's not so obvious. It's in there somewhere.
Yeah, maybe we should move it like to... Okay, it's in there somewhere. According to that design principle, maybe I can move it away from the wheel. $720. Let's upgrade this. And the symbol should move away a little bit. Mm-hmm. Who knows? That doesn't look bad.
Yeah, I like it.
You're gonna have so much sound from the underside of the snare into the cymbal microphones, but I think we will accept that, I think. Okay, so do we have measurements for the bass?
Nothing really yet. Chat, what's happening?
Yeah. Sleeping on your work.
Do I need to do that job? Really, this guy? Look at him. Can't trust this guy.
Sleeping on the job. So now. Okay. No more jokes now, because now we're heading into the CAD skeleton.
Oh, yes. Now it's serious.
This is serious. We're going to make our second sketch in the CAD skeleton. So the first sketch, we're gonna give this a very important name. It's going to be side. Side master sketch. Master sketch. Now we're going to make a new sketch. Should I just put it on the origin? Yeah, let's do that. Doesn't matter. We're gonna call this one top. So here, top.
Okay, here we go. €59 per eye. Toman gave me the dimensions. 110 times 44 times 10 centimeters for an Epiphone. Oh, he withdraw the message. Let's see if it comes an updated one.
Oh.
He withdrew it while I was reading it.
Oh no. Oh no. I'm gonna prepare then a sketch so I can take the measurements. Let's see here. I'm gonna make a new bass guitar. Let's take this away. Let's create yet another bass component. 0603X bass. And then I want some kind of plane.
A Boeing.
I'm gonna prepare. So this is another trick that I am like going on and on and on about. Should I do it like that? No, I shouldn't. This time I shouldn't. It's that I always project my sketches on sketch planes, on construction planes, and when I don't have a construction plane where I want to, I make a sketch to give me one. So this sketch that I'm creating now is only to make a plane. So I'm going straight up vertically, and then I'm going at an angle. So here we will be able to control the plane later. So let's put 80 degrees. No. Let's put 70 degrees. It's the same angle as the drums, 20. And then here we're going to set the height. So let's say 1000.
We got a CAD file with base data from Sebastian on Dropbox. If that's something we need.
Fantastic. So this sketch is to give me the plane. So I'm finishing this sketch and then I'm choosing plane at angle on this line. And there you can see I have my sketch plane where I want it. Now I'm making the sketch for the base on this tilted plane. So I'm going to see what was in that CAD file.
Yep.
So give me a pause screen because I don't have one.
Yeah, wait for it.
We can go to Duo or something.
Yep. No, we're gonna do this, and I will head over to your computer here to help you out.
So we are, let's say we are here. And then we go here, we go here, we go here, we go here, we go here.
Bottom.
This one. Oof, perfect. Oh,
Let's see what's happening over here. Whoa!
that's so cool. You can submit that. Is this probably your own design? It's a guitar though, but it's a beautiful CAD file. Or is it a 6-string bass?
It looks more like a guitar, right?
Cool design and beautiful wood illustration there. Base data. So what was the measurement?
Yeah, I got it now.
Yeah.
Exactly right now. For Epiphone EBJ CEBGCH1 Jack Cassidy electric bass guitar.
Yes. Give it to me.
142.2
In length.
Yeah.
Wait. It's like this.
Yeah.
And in width.
53.3.
Yeah, and that's it.
And then there's also 22.9. The height, right?
22.
So that must be the height and the width.
It can't be 20 centimeters.
That sounds ridiculous.
Maybe it was an acoustic one. I think this is plenty of information. So thanks everyone for sending in. Should be here maybe. And now I'm only going to sketch half of the bass. And then mirror it.
Generic other semi-acoustic bass guitar for comparison. So it's 125 centimeters long, 10 centimeters high, and 43 centimeters wide.
Oh, that's much smaller.
Yeah.
Other
semi-acoustic bass guitar.
Can you? It sounds, because 1.5 meters sounds so huge. I'm gonna take the smaller measurements. Yeah, it's 142 is huge. Is it maybe a double bass or something? Give me those. 125.
125.
Yeah.
10.
Yeah.
And 43.
Perfect. That little thing came crawling on your desk.
I'm heading out. I'm gonna prepare some thinking oil.
Wonderful, wonderful.
BRB.
Yep. So I'm gonna very crudely make a little body here. That drill you're probably hearing though. Do 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 do. So let's constrain this sketch. And let's see what we should constrain it to. Let's take this point. Let's start over here by getting 1 point constrained. Six, 8, 5. 670. So that will be the positioning of the whole thing. Now I just need to fill in the other measurements here. Let's do 50. Let's do 140. Let's do 20. Let's do 120. I'm just giving it random stuff. Arbitrary stuff, I think you could even say. 25. 590. I'm just trying to practice the rule of never leaving blue sketch lines. So there we go. It's constrained. I'm gonna mirror this over the middle line. When you have symmetrical shapes, then you should instinctively think of mirroring stuff. In most cases, that saves you a lot of heartache. There we go. So the good thing now is that if I want to change the body, I just change it up here and it will change on both sides. I actually want to pull this in a little bit. How can I do that? Never mind. So the interesting thing with the hit points, I want the hit points to the left of the kick drum, I think. So we should move the base to the left here in the image, which will be controlled by this measurement. When you constrain it correctly, you should be able to move the whole thing with this one measurement. So if I put 600, the whole thing moves to the left. So let's do even more to the left. Here. This is interesting. 450. So let's extrude a blocky version of this base. How thick is a base? Say 10 centimeters. No, it's not that. Maybe it is almost that if you think of all the things sticking out. I think we should make the drums a little bit more fun. And the base should be some kind of cool color. Not this gray. That was a super cool color, don't you think? I'm going to mark in the sketch where I think like the strings start. That's the wrong sketch. So we just get a little feeling for that, because there's like the hit point is not all the way back on the base. I just want to kind of mark that here. 50, 50, 50, and mirror this as well. There we go. And now we edit our extrude out of frame. And I'm deselecting that little thing. It's just a little marker. So now we can start to look. Do I have the CAD file in here? Yes, I do. Okay. Interesting. Good, good, good. Let's first of all take a look how this looks with everything else. The base position right now, so now I can update this. The base position right now feels like the big thing in the design currently. You can see fusion thinking. Done. Not done. Some fusion thinking pause music. So in our blocking model, we also have the Vibraphone. And I think it's time for me to start to block that into these new designs as well, so I can start moving things around. And if you missed it, because on the Marble Machine X we had a lot of problems with marbles on the floor, but we fixed that on the third machine. So with a proper sized funnel, this is form from function. Like, we do not want any marbles on the floor. By doing a proper sized funnel, we finally solved that issue. So that's one thing we don't have to worry about anymore. Let's now go to this and upgrade. We already did that. Apart from the base sitting in the middle of the drive shaft, I think it's pretty good. This looks very functional. This looks very functional. Let me also do the Vibraphone little quick. Because now when we're gonna start to look at the marble hit points, then we can look at all these instruments from the top. This is a step I forgot to do on the first machine, and it will help immensely. So I'm gonna assemble a Vibraphone here, just like we did the base. I'm gonna make a quick rectangle for all the Vibraphone stuff. New component, boom. 06, 06, Vibraphone. So same deal. We're gonna make a tilted sketch plane first. So just like this and like this. 70-degree angle. Comme ça. And this sits at a height of something. I'm hearing some thinking oil coming into the room. Oj, 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 oj. Fantastiskt. So let's make the Vibraphone on this sketch, and let's just make it like this for now. Right now I'm thinking one row vibraphone. I think 2 rows was a big pipe dream. But maybe not. Maybe not. Hannes Paradis.
What do you think, Wilson?
Cheers, everyone.
Cheers.
Cheers, Wilson.
I agree with you, Martin.
Wilson usually just says everything against what I say.
Yeah, well, he's been hanging out with me, Mr. Positivity, in the corner here. Well, wait.
Very good mug over there. Did you ever play some Turtles video games?
Oh, I love those.
They were difficult, weren't they?
Difficult.
Yeah. Not for the faint-hearted.
No.
I think they hear this drill, though.
Let's see if chat says something.
Yeah, they wouldn't if I wouldn't have said something. So let me just check quickly the length of a kind of long vibraphone plate. 32. So 320 here and a little bit less here. 160. Love it.
Still a lot of people are asking the question, how are you gonna play on this bass?
Yeah.
Yeah, explanation coming up.
So this is the trade-offs we're looking at on this position. You play like a standing double bass with your normal hand, which makes it very ergonomically, and we have a way to play this and everything. We can do that. This could still work. This is still an option. I haven't excluded it, but on the placement we're looking at right now, I would just play with my left hand on the side. This would actually be simpler to play than on the Marble Machine X and on the original Marble Machine. But my arm might be in the way for some marbles, and this is all the jazz that we're gonna look at now.
Your arm can be removed. Form from function.
Yes, it's true. Now let's see. Okay, I need to project this because it's not in the same. What is happening? We're not in the sketch. Aha. We are not in the sketch. There we go. Let's actually project this whole line. Hide other sketch.
FL3U3. Hello from Quebec. Go team hashtag.
Five. Hi in Quebec. I wish to visit one day.
Oh, nice.
Never been there. Never been in Canada.
No.
If Quebec is part of Canada.
It is.
I don't know if it's
as much as we refer to hockey in these streams, we should know that, right?
That's true. That's true. I'm going to move away from my principles by making a rectangular pattern. If you don't know it before, I don't like rectangular patterns in sketches in Fusion with bodies and components. It's okay, because I have the feeling they are breaking a lot of times. Might just be me mishandling them. Rectangular pattern this way. So the plates are 40 millimeter. Let's give them a lot of clearance. So let's give them 5 millimeters on both sides. It's just not maybe that much clearance. So we take 50. I made the wrong direction. 50. Yeah, I messed this up.
We already have somewhere to sleep in Quebec at least, because FL3 UV3 I own a motel if you will come. So you see, that's already sorted out.
That sounds super cool.
One step closer to that world tour. We got sleeping places in Quebec.
That sounds super cool. So let's make these vibraphone bars. I'm curious to see how many we can fit here. Oh. This looks kind of promising. What? Look at this. I managed to hit the last line. You know what that's called? You make your own luck. That's what that's called.
Ooh.
Dee, 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 dee. Yes, I would say like this is going to be one of the major differences, that we can properly design the machine for where the instruments are sitting. I'm just gonna check the thickness. It's like a centimeter, so minus 10 millimeters. There we have a nice looking vibraphone to feast our eyes upon. So the thing with this base placement, so my arm would just stick in here. But playing wise, it's not problematic. I can show you in the action cam.
Oh, yes, you can.
It would basically be like this.
There we go.
So it's okay. Like this. Yeah. That was it. I don't know if that made sense, but
All the sense in the world.
there you go. But it's trade-offs. Everything is trade-offs. And this is one of the trade-offs I want to look at now. Another idea is to just make a stick base without a body. If I want to be there, or put a height. Yeah, there's other trade-offs we can make as well. So let's look at one at a time, and let's paint this vibraphone a little brighter. Here we go.
Dan H. Nice demo. Now do it while Hannes throws drum marbles on your arms. Yeah, that's the main worry people have in chat, is all the marbles that's gonna be raining down from the vibraphone.
Yeah, so that's why. So good point, because the vibraphone plates can come over. Let's see how we're gonna do this. The vibraphone marbles are meant to fall in front of the drums anyway, so the marbles still need to jump the drums. So if we put the vibraphone a little bit more in front, so if we look on this from the top, so here you can kind of see that the bass is under the vibraphone. So the marbles, oh, here's one of our gates. See, we're already lining things up automatically. Wow.
Nice.
You make your own luck. So this is what we're going to look very thoroughly at here.
And you got the point, Luke Maffey. Doesn't matter if the floor is a funnel. You got it. And Bit Fiddler says, greetings from Korea. Nice to see you here again, Bit Fiddler.
Ah, nice to see you here. So I'm already over I'm already too wide because this is the programming wheel and it can be 110 centimeters. Let's see how wide it is. It's 100 this way. So I have already too many vibraphone notes. Let me remove some of the vibraphone notes.
Levin, you can play the bass with kinetic fingers, Martin.
Wow, that's not gonna fly well in chat. Maybe when all this is formed from function, maybe the machines, I will put one of the old kinetic fingers prototypes.
And I wonder which finger that will be. Just one finger sticking up in the air.
You mean a middle kinetic finger? That's okay. It took me quite some time. I got there. Yeah, so these are the big decisions right here, right now. But you know what? Maybe we can have our... No, there's no space. So we can make the machine as wide as we want to. We can make it wider to fulfill all our dreams in life.
Are we talking wider?
I'm just thinking, think if I build something that no one can transport.
Yeah.
Like my two previous machines.
Yeah, that was not good, not optimal.
How many notes did we say there was on a full vibraphone? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22 white keys. And here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 21. Okay. Are we going to go crazy wide? Honest 3000? And put the bass back on the left side and just make like an completely awesome thing and just solve transportation later? Like, if we're gonna do this, we're gonna do this, right?
Transportation will come to us if we build something cool, okay?
If you book them, they will come.
I have a great idea. Make it work.
Okay, that's a good idea.
So that's make it wider then.
That's a good idea. That's a good idea. I just... Okay, everyone. Hannes 3000.
Yeah.
I'm serious about this. This is the most best sounding mechanical instrument that have ever been built when it's ready. This is what I want to make it to. It's going to be the tightest. All the machines at Spillcock Museum from 300 years of music instrument history, they can leave the room.
Ooh! Throwing shade.
All the machines at Siegfried's Musikkabinet in Rudelsheim with the Wendell family, how amazing they are. But I want this machine to be tighter. And I want it to be cooler, and I want it to have expressivity. So what is a larger truck? Or that we have to tour with these cars that says heavy transportation on the road warning. What is that? What has the real world got to do with us? Maybe we should go back to the wide idea where I can be on the left side again. Because as I've been demonstrating before, what we dreamt of... So if we make a full-size vibraphone, we don't have to replace the keys, which means that our resonator tubes can be a fixed length. It just solves so many things. And also, if I just make a quick musical demonstration, we can make key changes, and you can play call and response. So you could play on the vibraphone with marbles. Imagine marbles, okay? I know it's hard. I can do this like this. Okay. Imagine marbles. And then key changes. Marbles that can play like that. How cool would that be?
Tears are
Tears,
streaming
right?
down my face.
What is a road vehicle warning for like wide cargo? What is the higher of that project compared to some key changes? I don't know. Maybe it's feature creep. I don't know. Because yeah. So okay. I'm gonna bring the audience to exactly where I am in my mind right now. I'm at the CNC. I'm at the rotary CNC machine, and I'm at like. So this has a max capacity of 110 centimeters. There's probably a lot of machinist places all over the world who can cut much wider, much bigger. And maybe we shouldn't even like cut this ourselves. We should just hire this job from someone. But this is where my mind is like, if we should try to keep within this, or if we should just build a monster of a machine.
Here we go. Nothing compares to that. That's the goal. It has to be. People are with you.
I feel like this is the time when we're going like industrial. This is wait. Form from function, right? And I feel a little stupid because I feel I want to be responsible. This is my conundrum right now. Here's my programming drum. I don't want to design something that is impossible to use. And I mean, if we design it this big, no one else will want to deal with these kinds of things ever, because it's not like a grand piano, it's like 10 grand pianos.
Son of Atreides, if shipping isn't a constraint, the manufacturing shouldn't be either.
No, that's a good point. So let's just for once dream a little, okay?
Yeah.
Because I'm tired of running out of space.
Lee Smith, design it to work first, tweak it to be compact later.
Yeah, I'm with you in spirit, but this is such a major thing. So there will be no going back. We have to rethink it. But I think you're right in the like we should just do it now, and then like yeah, I think you're right, because I can't think of all variables at the same time. Let's just see what happens if we do this. What happens is that we can have a full-size vibraphone, maybe even with extra notes for the fast notes. This is such a crazy thing.
Peter Vasta, go for big. Yeah.
Because here's what sparked my feeling. Namely, we can put the second row of the vibraphone of the black keys in front here. So let me head over to the vibraphone sketch. I just don't want to live like in a I just don't want to live like in total like fairyland. Or or do I?
Peter was again here. Dude, you're on Model 3. Go for your wildest dreams. Just keep function high on your list. You'll regret a little limited machine.
That's very nice.
Milan Cora, in mathematics, you always develop before simplifying.
That's right. And that, yeah. I like what I'm hearing. Thanks for this pep talk here.
Cogno Marco, can't you just put some notes from 2 keys instead of having all notes?
Some notes from, do you mean 2 keyboards or
I don't understand why you can't have key changes with fewer vibraphone notes. Just put notes from 2 keys instead of all the notes and using only some of them.
Yep, you're absolutely right. You can do that. If you go back to the idea to change notes out, to have a few positions. So that's another like big design fork that we're having now. Are we going to build in the functions that you can change notes out between the songs? Or are we just going to, because you need to reprogram the machine anyway, or are we going to have like a full scale vibraphone, even maybe with extra slots? So one idea we had is have some extra slots to be able to repeat some notes faster, because that's another design constraint of this machine, since we're not dropping 2 marbles on one note, that if you're going to play like things like you can basically not play that. Then you need to go it on 2 octaves, like you need to play fast like that. And then the idea is to, if you want to repeat this note, then you put an extra of this somewhere on the machine just for that song. So you can have a full chromatic thing plus extra notes. That would be epic. Yeah. Let's make a rectangular pattern of this lower row. This way, 50 millimeters. And how many do we want? Something like that.
Erik Hertel, the rebounds angle on a sideways string is chaotic.
Yeah, so can you pull up
the hammer jammer?
Hammer jammer. Good point. The marbles are not going to hit the sideways string. They're going to hit the hammer jammer keys. So we can show that we found a new cool video of a hammer jammer today. Let me make another extrude feature here. Now I can only extrude the keys that are in between the drums. Uh-oh. Here. Yeah, so Hannes is just going to show this. So if you think of the plates that the bass player is hitting there, the marbles would be hit straight on them, so it could work. So let's give credit to this YouTube channel again.
Big Walnut Music.
Big Walnut Music. I think that comes in the end, the credit. So that's a video from Big Walnut Music YouTube channel. So here is my idea for the lower row. We can exclude where we want to hit the kick drum. So I'm going to exclude those two. And then I'm just going to fill everything in between. This is not like a regular piano pattern. It's just in between here. Gonna mess people up. Ooh, if we do this, we can maybe get the extra note in. Look, here we exclude 2 for the snare drum.
Make it possible to disassemble for transport. So people are a little bit torn here. We have a lot of people who are saying go big, but also some things should be kept in mind also.
Yeah.
So we're right back where we started. We're in the land of compromises.
Yeah, that's design. That is design. So you can see I left some holes. I'm not making a piano pattern. I left some holes open, and that's over the 3 drums there, and over the middle point of the 3 drums. So let me use our favorite feature, the offset. Weren't you longing for an offset feature of today?
We are joined here today.
This is inside baseball because we had a person in the chat who wanted to marry the offset feature when they found it, and I have the same feelings.
Yeah, brilliant.
So if you can see now, I'm using the same sketch, but I'm offsetting where I'm extruding it from, so I don't have to make a sketch in another plane thanks to this 100mm offset right here. Okay, we're maybe not fighting the dragon, but we're like negotiating with the dragon right now. We're at the cave talking to the beast. That's how it feels. I love the irreverent piano pattern, that it looks like a piano pattern, but it just isn't. I love that. I would actually love if it was a normal piano pattern as well. Do, 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 do.
And the idea is being lifted again that we talked about last week, about having like basically 2 machines that are connected, so you can split them into 2 and connect them together.
Yeah, that's where I feel that feature creep have destroyed the design. So on the first marble machine, which has 200 million views on YouTube, we had 11 notes. If we could do it with 11 notes, we should be able to do it like with 20 on this one. And if I would just like accept to exchange the notes, yeah, it's a super tricky trade-off in my mind.
Yeah.
Okay, let's now then also bring into the fold the standing bass also.
There we go.
It's a big one. I mean, you can't deny that this thing looks like it can play music.
Oh, that's a concert right there.
So now let's start to look at the thing that I wanted to do from the beginning of all this, which is the CAD skeleton. No, let's not do it here right now. Let's do it where we see the instruments. Let's do it here. So I'm going to create a top master sketch. Oh, wait. Top master sketch. Create sketch here. what I want now is I'm thinking about the programming wheel. And what I want on this machine is that I want everything to be in line with each other. So let's say we start with the first plate here. And then, since we have 50 millimeters between the Vibraphone plates, then we can make a rectangular pattern on 25 millimeters on this line. So we go this way. We want minus 25. You can see now we're hitting the middle of the plates. And here we go with the number of programming channels. 60, 50. I want to be able to tell stories with this machine. On the other hand, it's only a loop. So like key changes needs to happen. My whole talk about key changes is kind of crap because we only have a 64 bar loop, beat loop. So then any key change would just be repeated over and over again, which kind of goes against the whole spiel about key changes that I did earlier.
Mm-hmm.
So 44, 43 channels. Like this. Can I make them all construction lines? Yes. And now I can place the hit points. Just gonna put them more in the middle like this. And then the whole idea is that you have to do a zigzag pattern. We did that in one of the first streams. Wait, let me pattern this as well. Stupid. I'm gonna do 40 millimeter hit points. Just to make them, no. Let's do this. What are people saying?
Yeah, I'm just reading here. Peter Vasta sent a nice comment here again. When you're done, you should make a documentary about your lessons in design and engineering you have learned. You are the musical Elon. Wow.
I'll take it. I'll take it.
And I also have a message from Bjarne L from Denmark. So it's in Danish. I will try to read it, but my Danish is not very good. Låt vara med att begränsa av bredden, Martin. Du kommer till att förtryda det. Fyllt dig från Marble X. Bjarne Alborg. Danmark.
Det var fin danska, Hannes. Nice Danish. It was basically, don't limit yourself, you will regret it. Go for it, right?
Yeah. But also people says to me also, remind Martin, don't always rely on yes men in everything.
Yeah, that's a good advice. I'm gonna show you something about the rectangular patterns that I do like. So when you have an irregular pattern, so as you remember, we did holes here. We don't want hit points at all here. And I'm making a pattern. And if you go up to this suppress feature and hit suppress, you get these tick boxes and you can deselect where you don't want the pattern to repeat. So here we don't want nodes. So I deselect there. And let's deselect the other ones. I deselect here and here. And this way you can make patterns that are irregular. And it's very, very handy. So now when I hit enter, you'll see we get a nice sketch circle. Oh, because I hit the wrong. It's me. No, it's you.
What's happening?
It's me.
Okay.
It's me, it's not you. So now you can see we have nice hit points on all the keys. This leaves us space here for 2 hit points on the hi-hat. This one. 20. And this one. Hit point on the... Actually, the hi-hat I want to hit here. So we should maybe move the hi-hat back. Okay. We'll look at that later. The snare I want to hit kind of in the middle. So it will be here. And notice that I'm now using a channel down here on the snare that has not been used up here. So I'm doing the zigzag consistently.
Michael Macmacken. Martin, if you have half a vibraphone off to the side that isn't connected to channel at all, you can play something in another key that isn't repeated.
Yeah, that's a good point.
There's a little improvisational.
That's why I like to
vibraphone.
Yeah, and that's why I liked to stand on this side, because imagine when I use the foot pedal down here and I play the bass, I can play like a keyboard with my right hand, this hand over here. It can play like a keyboard like this.
Yeah, I can see it.
So I could actually just put a normal vibraphone next to me. Then it feels like the machine itself has failed if it needs. But it's a good point. Everything doesn't have to be...
Android 78 then. What if you had 2 vibraphone plates at each position mounted with one at 90 degrees that you could rotate for a key change?
Wow. Like a little...
Switcheroony.
So then you have to also do a little switcheroony on the length of the resonator pipes, but cool. Cool idea. So we're here, we're hitting the kick drum, it's good. We are not hitting the bass at all so far. So, okay, let's just take us where reality leads us. So I'm making a zigzag pattern on the hammer jammer. Our imagined hammer jammer. Give me some more lines. Yeah, I have a massive conflict in me right now, as you can probably tell.
Ludwig Schubert, no need for yes men or no men, just verify your designs against the door opening of a shipping container.
Okay, so honestly, this is a very good thing, because we put a shipping container into this blocking, and I think this container must be the smallest model available.
He included a measure here that's 2280 times 2310. This opening of a container.
2280 times 2210.
2280 times 2310. How big is that one?
Is that a standard done?
Let's see what chat has to say.
Because if so, we're totally screwed.
For now, we can unscrew ourselves.
So, standard shipping container opening. Yeah.
There's no smallest model for containers.
Let me see the damage here width-wise. What is this? This is not so bad. I'm only on... What's this? Hey. We're only on 120 here. What? That's great news. Still with the base lying though.
So yeah, people are saying there are container standards. Then write standards for me, please. There's something called high cubic containers. There is a high cube mode where it's 2.9 meters tall and 2.4 meters wide.
That sounds like our container. Let me get that down. New design, new component. High cubic container. Are we talking the door opening or the outside measurement?
I think that's the outside, and then there's, I mean, the doors, shouldn't they be the same?
No, the wall has a thickness as well. So can you repeat?
2.9 meters tall and 2.44 meters wide.
Oh, I put it wrong. 2.4.
2.9.
No, wide and tall. 2.9. Look at this.
2.9 meters tall, 2.44 meters wide.
Yeah, I have it. 2.44. Look at this.
No room for pallets or any kind of material around it.
So there is a world where we reduce our programming drums to 800 millimeter diameter instead of 900. That's also a world. Let's see if we can see the sketches. Yes, we can. Okay, we've been talking with the beast. This is tripping me up so hard. So my arm, if we do this, my arm will not be an issue. My arm will just be under the vibraphone plates and the marbles will jump over my arm. And the marbles will hit the front of the hi-hat anyway, which is good because that's where my elbow is. And my fingers are here. So my arm is not in the way for the marbles actually on this base position. And I'm having so many vibraphone plates without going wide. Without going like crazy wide. I could also not make the pulley in the drum and we can reclaim this width of the drum. If we want to keep to the 110 constraint. Of course, this is not enough. This is 120 with the programming tracks. Okay. Maybe I should put the same base sketch here. Because this one looks a little crazy. Oh, this is tough. This is tough.
Can you lay the machine down during transport? A lot of people are wondering.
Probably the way we will build this one, it should not matter, but it's going to be so heavy.
Yeah.
So probably you don't want to tilt it. And I think generally when we get to that scale, there will be stages that can't hold the machine. Of course, we all knew that, but I mean literally can't hold the machine. So it's the cozy clubs are like all out. Only the cozy clubs with big enough entrances are possible. We're gonna play in conference centers and airport hangars. Airport hangar tour.
Andrei Nedelka, Confucian 360, a mighty tool and evil master. We believe that this will be your opus magnum.
Oh, thank you. Thank you. I think so too. Actually, right now I think so too. It's just a
lot of stuff to take into consideration.
Yep. This is probably, but this is a super good trade-off to be wrestling with. It's probably the hardest trade-off so far. Like, should I just go wide and have space for everything? Or should I? Because real engineering is actually to be resourceful. So, like, if I say, yeah, this is going to be 100 meters big, and guess what? I got a lot of functionality in. It's not good design. Good design is like, yeah, we on a compact footprint, we got all the functions we want. That's good design. Yeah, okay. You know what? I'm going to pivot a little bit. We're gonna marinate on this.
Yeah.
Because this was a lot of good new thoughts. I am going to do something cozier because I think I'm going to CAD some real parts that will maybe be on the machine. I'm going to pivot up to this little intriguing force field right up here. This is the PUM bushing for the registrators. And so I'm going to leave this discussion for now and return to it probably many times. On the other hand, we can actually get some information because right now we have a center between programming tracks of 25 millimeters. On the Mark Machine X, we had 17. So pretty chunky, and which is interesting. And this we can remember, this 25, we should remember when we design this little part. So let's get straight into the registrator assembly, which we were working on this morning here. And I'm going to work on this POM bushing right here. 25. Some thinking oil. How's Wilson?
How is Wilson? Let's check in on him. I'm fine, Martin. I'm enjoying the view from up here. Thank you so much for letting me join this stream.
What has happened? Have you made Wilson finally submit Hannes 3000?
Yes. I learned him manners. Oh no, that should be my voice. I learned him manners.
Okay, let's make a part. So, I want to use a lot of POM and Delrin on this machine. I really like how that functions. And I'm just going to try to save this. And the other day I started on this POM bushing, which is sketched there. So let's see. Here we have an extrude feature. So this will be the side to side, and we said 25 millimeters between channels. So let's do exactly 25 between channel centers. And then this thing that comes down, I think should be a laser cut steel profile. I'm just gonna see how I can do to save this.
A lot of people are shouting out in chat that we should just use open top containers when shipping it.
And if
But
it's
I mean,
rain?
yeah, that's my whole deal as well. What about weather then?
So I had a fun idea here. So if the thing going down is a 4mm laser cut profile, if this little thing is a 4mm laser cut profile and we want it to sit in the middle, this should be extruded at an offset of 1/2 of 4. I'm going to show you where I'm going with this. I kind of like this design. So again, offset is very useful on the extrude commands. So -2, 1/2 of 4. And then distance is going to be to an object to this side. I think something went wrong. I think the offset shouldn't have been negative value. So I'm going to edit this feature and just say 2. There we go.
Just gonna show you really quick. Someone at Discord actually just posted all the standards for containers if we want to have a closer look someday here.
Oh, fantastic.
Nice, right? Thank you so much. GSAT.
2261. Yeah, that's awesome. That's awesome information. Do you have it in our images now then?
No.
Was that from Discord?
Yeah.
If you can upload that image to Dropbox, we can have it in our archives. That would be fantastic. So I was thinking how to make this bushing with a one-sided CNC operation. By the way, does Delrin come in... Why is this 22 now? This should be 25. Hannes 3000, can you see if there are 25mm thick Delrin stock? Probably. Probably. And here's a little, do we just thread the Delrin and just put the things into the Delrin, or do we actually have a nut on the other side? Then it's a double-sided machining operation, and it's most of all, it's overkill. Oh, if we just make this a little bit bigger and the nut sticks out, that's a nice idea. That's a nice idea. So the nut just goes outside here. Probably the simplest. Makes the part a little bit larger. Let's think about that later. Let's make the steel profile so you see where I'm going with this. New component. 070X. Registrator steel profile. Never mind spelling.
You have white Delrin here. 25mm, right?
That's a pipe. It should be flat stock.
Well,
25 millimeter thick flat stock. Sorry, I wasn't clear. So let's now sketch the profile. This should be parallel to this. That's
Delrin sheet, 10 millimeters to 50 millimeters.
15?
50.
Oh, that's heavy. Do you have in what intermediate steps? Is there a 25 intermediate step?
16, 20, 25, 30.
Perfect.
White.
Nice. Thank you, Hannes 3000.
Well.
I mean, everyone wants a Jamie, don't they?
Mhm.
And now I have one. So.
Barnstormer 322, one of many voices saying the same thing here. Martin and Hannes, please just dismantle the machine into large chunks for transport. It will be so much easier in the long run than making the whole machine robust enough to take a knock in shipping.
Okay, so we're talking about... So there's, of course, two different kinds of shipping. It's like crossing to other continents and like when you're on a... So when you need to like leave land and when you're on in a truck. And I guess like inside a truck, you would just roll the thing onto the thing in the back. You would roll the machine straight into the truck and you would cover it with like something inside the truck. You will fasten it. So that's probably one scenario. But then it's when you maybe go from Europe to the US, how you do like on the boat and stuff.
Yeah.
And the disassembling and making sure everything works again, designing every little fastener for coming loose and coming in, coming in.
Everything doesn't need to be modular, right? Can't you have two big pieces or something like that?
That's a huge design constraint.
Okay.
Like it's like having a welded frame or a screwed together frame that's just super rock solid and the whole thing in a chunk. I think, I mean, everything is possible, but it's a huge design. I learned it from the More Machine X. The way that we tried to build it in 5 modules made everything 10 times harder. Less dumb design requirements. I think we should really go for a machine that is ready to play during transport. And you come in, if you want to tour also, imagine being able to play a concert in each city every night. So you end the concert at 12 o'clock in the evening and you drive tonight to the next city. In the afternoon, you make a sound check. The machine has not been tampered with during the night. So, yeah. I should drink from this mug instead. It's so hard to drink on stream.
Haven't learned that yet, have you? Well, you just have to prove those in doubt then about the shipping.
No, those in doubt are correct as well. That's why I'm annoyed. So this is the new awesome idea, I think, I have that we made the registrator who is adjustable with set screw. So I'm just going to put this arc at 472.
Going where the puck is gonna be. Kazakh, just build wheels on the machine so it can drive itself. Problem solved.
Fantastic. I mean, if it's this big, you can just roll on these rollers. I can make a little cabin like this, and it's a tractor. Look at this.
Woohoo!
Imagine you sit up here and you just go like this across the US. And then you just make a wheelie and tumble over, and there you go. Concert's ready. Imagine you have the intro live. You all of a sudden you hear like tumble over like this. What are they called? Monster trucks.
Yeah.
And then, and then.
Oh my.
Also, the asphalt will be super flat wherever we have toured, okay?
Wow.
I will get paid by the road authorities to like tour a little bit extra. Never mind. Where were we? I felt I was getting somewhere with this. This? Yes, here we go. Okay, so now we're actually gonna CAD actual parts and not only think about placement. I'm happy for that. Let's offset this 10. What's happening here? And that was stupid. I shouldn't have done it. Let's offset this 10. No, I don't want. So earlier in the stream, we checked some suggestions and it was like super high level actually on everything. And we found an issue now. We have so many suggestions, so we want to look at the suggestions that are related to the stream we're making. So we're going to update our submission links and we're going to make like different links for different categories. So you can sort your suggestions into the proper category. And then even if you want to see how we react to your suggestions, you can even see on the thumbnails, like, okay, this is probably a stream where like if I sent in a suggestion regarding the programming wheel, we're going to react to that in the programming wheel stream, basically.
So we'll have that set up probably for tomorrow.
Yep.
Yep.
And we're also thinking, actually, we can actually ask everyone here. Because we don't know if we should make fewer streams with and kill the stream in between, or if we should make longer streams with breaks like we did today. And we've been thinking about fun things to put in the breaks. We were thinking about slideshow with the suggestions. Is one very, very simple thing. Do you have any other ideas of, could we put something useful while we're like having lunch and leave the stream up? What would be a fun thing to put in the intermission to make the intermission like a little more functional and useful? If anyone has an idea about that,
Great.
I'm very curious.
Here's a fun Swedish comment here. Trevligt att se att du inte gett upp från en gammal barndomsvän, Tony Åmark.
What? Tony Åmark? Hey! Me and Tony Åmark were skateboarders, and we haven't talked for 25 years or something.
Woo!
Maybe 20. So fun to see you here. I'm in our old hometown sometimes. We should definitely meet up. Are you still skating?
Woo!
Tony was always better than me in skating. Like
with a name like Tony.
yeah, okay.
Tony Åman, Tony Hawk, you know.
I was afraid of pain, and Tony was just going for it. That's how I remember it. So let me know, Tony, how the skating is going. Super fun to hear from you.
Bitfiddler, leave it running with funny stuff from old videos playing. Adam Gaming, More Machine X building montage. Intermission should be your music, but even on a blank screen works. Wintergatan music videos, Marble Race.
The Marble Race on repeat.
Long streams with breaks, but put something in the break as well as a timer. Maybe the previous summary video on loop until you return. You can put montages of the old builds during breaks, please. Play a loop with the latest recap from the main channel.
Oh, that's creative. Because that will get everyone up to date. So if you're just joining a stream and then you get the recap, that's a brilliant suggestion. Can you like copy paste some of these suggestions? Tony, I almost called you.
Hey!
So I'm gonna extrude the steel profile here, as you can see, and we're gonna do it symmetrically. And now when we go here and we can make the P1 bushing a little nicer color, I think my design idea for the bushing becomes clear. So I think this is a really sleek bushing. Check this out. So the steel profile is completely centered on the programming track. You can see it here. And the bushing is a one-sided machining operation. And it will hold this profile very, very straight and steady. So I think this is I love this design. It's so simple, but I think it's going to be very, very efficient. I'm gonna fillet this. And I almost filleted it here. But no, don't do that. Make your fillet in the sketch. So let's do that. Wrong sketch, of course. So I'm making the fillet in the sketch, which is the better way to do it. And then you can just make a radial line and then you say tangential like this. And then you add the fillet size. Boom. So then you have your fillet automatically when you're extruding your part. If the extrude behaves. What's going wrong here? There we go. So now we need a hole here. Oh yeah, I was thinking about this. How to hide. So if we come in with M4 fasteners here, should we have bow nuts on this side or should we just tap it into the Delrin? My experience with Delrin is that it takes fasteners super well. It takes a thread super well and it holds them. I think there's no stress here. I think we should actually just make it exactly like this. Maybe 4 holes. 3 or 4 holes, chat. All the engineers out there. 3 or 4 bolts. What do you think? Maybe this bolt hole should be away from this. For some reason, it feels better to leave. It feels like it's weakening here. It's so strong. It's not weakening, but it feels like, I would like to turn that around.
Tony har svarat.
Okej.
Ingen skateboard längre för min del. För gammal. Dock fortfarande bosatt i Karlstad.
Oh, nice. Okay, so no skateboard for my childhood friend. Me neither. There's some snowboarding occasionally, but still, the fear of pain is keeping me from making impressive tricks. I do have a tail grab on a snowboard in a video from a year ago.
Yeah, I've seen it.
It's called value of time and concentration or something like that. Attention is the cash value of time. Did I even title the video that?
Probably.
Pretentious. So my next question is where we're gonna put this pivot point. So if you see this, somewhere we need a pivot point that will attach to this. And I'm thinking if we roll this to the right. Now I have an interesting idea, Hannes. If we move this to the right and we put the pivot point down here, let me show you that. If we actually put the pivot point, there's a lot of imbalances. It's the whole pushing thing. Oh, we can even have another arm. Whoa. Let's put it here. And let's connect this with, let's make another arm here. No, then we can't, because we're gonna have the POM part coming in here later. And we can't get it on there. Okay. So let's not do that. Let's keep this part smaller as well. Let's put the pivot point here. 4. There we go. And in the extrusion, we're gonna deselect this little thing. So I'm going to mirror these hole placements. I'm gonna take this away from here because it doesn't feel right. It's so nice to CAD something that might actually be used. Which is unrelated to these big questions. And I think that's how I will do it. I will sometimes go on big questions and then I will go down to small details and I will change perspective back and forth.
Yeah.
This should be 7.2. 7, okay. 7 is M4. Oh yeah, we don't need the nuts anymore. Let's remove this junk. And what is even this? 4. Three or 4 bolts, Hannes 3000.
What did you say?
3 or 4 bolts.
3 less parts.
Is that what chat is saying also?
I saw someone saying it earlier.
Yeah, it's enough. It is enough. Look at this. This is so clean. This is so clean. What is this? Gretzky stick. We have Gretzky stick. So I'm gonna make the hole in the POM the correct size for an M4 tap, which is 3.3, I think. And I think chat or 3000 can tell me M4 tap is 3.3 or is it 3? So drill size for M4 tap. We have to reduce the latency of the stream, I guess. Because this is taking forever.
What is taking forever?
Drill hole size for M4 tap.
Aha, okay.
I'm joking. It is 3.3, I think. And then when you do it in Delrin, you can actually use a little small drill if you want even...
It's 3.3.
It is 3.3. Okay.
Tuscan 92.
Thank you. Sometimes it's hard to get to these constraints. So I'm trying to choose... Oh, I'm going on the wrong one. Here, circular pattern constraint. Then I have to choose it and then I can edit it. Because I want to include this 3.3 circle. There we go. So for the POM part, I'm going to make the holes a little tighter for the tapping. There we go. So now you can see that the metal part is larger. And the metal through holes, let's put some tolerances in. Why not? Just because it's fun. The metal parts should not be 4. We're gonna do 4.1. So there's just no issue with the bolt coming through. And the inner diameter is going to also be just 40.150. I guess. No, that's ridiculous. 40.3. I mean 23.3. That's what I meant. 23.2. Let's just deselect this little thing. So in CAD, it's always nice when all the measurements are perfect, but then in reality, when there's a little burr from the like laser cutting of the metal profile, and this doesn't go assemble well, and you don't need that precision anyway, then it's better to just give you more space and everything just clicks together and comes together with the 3 screws. Nice.
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 And Goober here, he says, I found this channel from yesterday's upload. Are you two living together? And first of all, welcome here. So nice you found us from that video. And no, we're not working together. We are not living together, but we're working together. But I mean, this would be a brilliant sitcom, wouldn't it? The three of us here living together. A friend situation. Hannes, Martin, and Wilson.
If I fail with the machine, it was a sitcom.
It was a sitcom all along.
It's going to like turn into a sitcom after the fact. So I can't get over how nice this bushing is. You see how centered that metal thing is? And like it's going to be constrained in all the directions. It's great.
Wow.
It is great. So now we are going to make the reader that is going to slide along this hockey stick curve. And
Bit Fiddler, 2 men and a gear.
fantastic. That's fantastic. I'm thinking about that cage we saw earlier because I'm going to put this bolt in here now. And we talked about how to...
Yeah, 2.5 gears. Michael Soka. Brilliance.
Let's first make the... So I had the idea of making a bend. So I'm gonna CAD it as if it was... let me see how I should do this. I want to keep it parametric as well. Yeah, I'm gonna make a bent. I'm gonna make a flat pattern that is supposed to be bent. Here. I really don't like the pushing. Yeah.
We're back at it.
Well, it's all right. It's all right. It's all right. It's not gonna be an issue. So I'm making a little line here for a new, how should I do this? For a new sketch plane, I guess. Let's try this. So we put a plane at this angle. There. We put a sketch on that plane. There. We project our nice little profile there. And we want to come out to the side. Not like that. Like this. Oh, yeah.
Ooh, yeah. Rabba-dabba-doo.
Do it 10. And let's do these. They are at an angle. We do not want that. Let's do these like this. And you are parallel to you. And you are 4 millimeters. And when we set this length, everything should turn black. Almost. So we can say that you are equal length, then that inner curve turned black. So 25 is way too excessive because we know that we only have 25 between center. And so I actually want to know, I should constrain this to the center of this line. So let's put a little point at the center. And you see that little triangle right there? We're at the center. So, and we want a lot of clearance to the other stuff. So now our whole sketch we did in the beginning of the stream with the channels, all these lines. Now I'm using what we found out with these lines in this little decision right here. So we have to keep within the complete width of 25 centimeters. So we have a maximum 12.5. So we're in a little bit of a spot of a bother here. So maybe this idea is not going to work with the bend. I can just show you I wanted to do this to hold the bolt from the front. Let's see if we can, if this radius can be reduced somehow. You are perpendicular to you. And you are only 5. Okay, that's better. Wait, there is no metal there on the other one, is it? Oh yeah, I'm stupid. We can go over there because there is nothing on that side on the next channel. So we can actually use, because look here, on the left here there's nothing. Good news. I just forgot that we had empty space there. So let's go back to a little bit of a bigger radius. 8. Okay, here we go. And let's say 15.
Buckle the seatbelts.
Here we go. Yes, as I said before, we're going to like go between the large perspectives of the big design decisions and the very small perspective of things like this.
And Tim Keller joined the chat.
Nice.
As always, I will take me $50 slab of honey steak now. California love. Tim has entered the chat.
Nice to see you here, Tim. 1 millimeter. I'm gonna make you proud, Tim. I'm gonna make you real darn proud. That's the idea here.
Oof. Magic.
So, can you bring up the cage that someone submitted?
I will try.
For the holding the bolt. Then I can show that like that this is the same idea. 3, 7. Yeah, so this is what I'm working on. So this was the proposed.
Let's see if I can do that a little bit smaller for us there. Something like that, okay?
So I think that would be more like a 3D print. This is not really like a machine thing. You can machine it, but it's kind of an expensive part. So this is a really nice idea, and I'm going to try to do the way with a C clip, like we did it on the first time because we already designed this part a little rough on one stream. So, but this cage is solving the same issue that I'm trying to solve right now. So yeah, you can. So thanks to whoever sent that. What was the name?
Elder Baseman.
Elder Baseman. Let's put this as a band.
Alexandre Freitas. Any possibility of a Q&A live anytime? I don't know, Martin. How do you feel about that? Kicking back, relaxing at the end of a stream, perhaps sometime.
Yeah, we could do that sometime if it's if there's interest. I think half of the audience would. I think stuff like that is fun, but I'm also thinking maybe it should, if it's helping the Marble Machine 3 get progressed, then yes. If not, then no. That's I think that's the
Yeah, it would never be a scheduled Q&A at least. Perhaps when we have some leisure time at the end of an evening or something.
So there's always, like, during the streams, many times I just need to do things that I can always take a chance with Hannes 3000.
It is almost like a Q&A right now.
And
I pull up some questions now and then.
I mean, that was the first question of the Q&A, actually.
Yeah, and we wrapped.
So I know when you send in things to manufacturers like 24/7 Steel, they don't like when you ask them to bend things over holes like this, or they will say like this can be imprecise, and then you have to approve it. So I think I should move my hole a little bit away from the bend. And I'm also thinking that maybe M6 is unnecessary here. M5. Let's do 5.2. Oh yeah, I made a slot here actually, didn't I? Because of the angle of the thing. Yes, point here will not suffice. We need
Second Dynasty here. Said, what is this leisure time of which you speak? Shout out to our dear friend Ben right there.
Sven Mogren from Second Dynasty. It's in the chat. They make 3D printable spaceships. They are awesome. Where should people check them out?
Second Dynasty?
And I know, Ben, you were not fishing for a shout out. I'm gonna give one anyway. Because you're awesome.
Yeah. I mean, they have a YouTube channel, so they can check it out there.
But it's on My Mini Factory. It's a better place, right? To check out the...
And Kickstarter, they do both, right?
Okay, they do Kickstarter.
They have the promo videos, which I helped some of. I made some of them. You know.
Yeah, they're awesome, the promo videos. Center point slot. Let's do this. 5. Boom. So the reason that this is a slot is because the thing that the screw is holding is walking across this arch. So the screw will be angled upside down. So there we go. So it's not a completely round hole, it's a little bit of a slot to give space for the bolt to move up and down. Wait, I want to cut these corners off. Sketch fillet. It took me ages to find these sketch fillets. I can't do it on projected lines.
Sketch fillet.
This is annoying. Sketch fillet. Okay, I'm just gonna do it like this. 4, 6. Boom, boom. Boom, boom. Why don't I just make it? I'm so stupid. I think that I need like a better starting point, because I can just do this and it will look cleaner. You with you, you with you, you with you, you with you, and everything tangential. And then we have our fillets in the sketch instead of a feature. Right, Tim?
Are you still there, Tim?
I'm here in California, love, right? Three. I can't wait showing everyone what I can do, what we can do together. This, and honestly, completely honestly, if we find out in this CAD that I don't believe in the project, that I don't think that the machine will work, it's going to be so nice. And then I know that everyone will understand why I will give up. So regardless of the outcome, as I usually show, there are 2 possibilities. Finish the digital CAD model first. That's what we're doing today.
Ooh.
If CAD is promising, less manufacturing physical machine and go on a world tour. But this alternative 2B, I'm also happy about this one. If CAD is not promising, that's the moment when I can give up on this idea. So
win-win in every scenario right here.
yeah, it feels very good. I love this design. Let's see. Let's enter the... So, Hannes 3000, can you find a M5 E-clip?
M5 E-clip.
Oh, I'm stupid. We have it in Fusion. Insert, oh, sorry, wrong button. Insert MacMaster card component. I should not ask you to find things that is already here.
Tim Keller, the chance of you designing this and not wanting to build it is 0.
Okay.
We can be honest about that.
Metric side mount external 5 millimeters. Heavy duty side mount external retaining rings. Did you think you would ever hear those sounds in your life?
It was a thing of beauty.
Look, they even have low clearance side mount for tight spaces. I don't want that though. Heavy duty side mount.
Heavy duty side mount.
Read it out then. You started it.
I can't really see it from here.
Uh-huh.
I'm sorry.
Okay. Black phosphate spring steel, stainless steel. I don't know what's normal here. I'm gonna take the cheapest one. No, package quantity. I'm gonna take this one. Step download. Here we have.
Wow.
My first ever E-clip. Oh, it's huge. Wait for it. Is there some kind of radius here? Oh, yeah. So I only worked with C-clips. Oh, wait. In this new design, we can have a C-clip. Because in the old one... Yeah, no, I don't want this. I want a C-clip. Let's throw out the E-clip. The reason you want to use an E-clip instead of C-clip, I think sometimes is when you're out of space. But we're not out of space here. We have space to assemble it. So let's have another go. Insert McMaster car component. The best thing with US is McMaster car.
Okay.
We have so much McMaster car envy over here in Europe. C-clip. Those are not my... So someone said they're called C-clip, and I said circlet clip, and everyone, no, it's C-clip, right? And look here. Okay, external retaining rings, self-locking. No groove is required. Release the spring into a groove. This is the one I want. Heavy duty external, thicker than standard external. These rings withstand greater force. What do you think? Which one? Let's try the heavy duty one. Oh, probably no. 12 millimeter. I'm wrong. Normal sizes. So then you just go here and you say metric. In 10 years, the inch alternative will not be there, hopefully. For groove meter, 4.8 millimeter. I don't know how good this works on a bolt, actually. Here we go. C-clip.
Circlip.
Circlip. Isn't it beautiful? What do you think? I should join it. I should not move it like this anyway.
Both C-clip and circlip are accepted. Circlet, no. I googled it yesterday. It was something to do with styling your hair, I think, right?
Circlet.
Circlet clip.
There's something else. Okay, so I was wrong. I'll admit it, I was wrong. How big is this? Oh, it's so annoyingly small. I'm thinking I should go M6 on this. Because if we're gonna thread the POM, I like big threads. Maybe this is unnecessary. Am I being unnecessary now? Yeah, M5 is enough. Okay. So we have that one. Let's make how should we make this? Should it go straight? So I'm gonna start with the POM part. New component. Boom. So this is the part that will read the programming pins. 07, and we can very accurately move it across with a set screw. And this, we couldn't do that on the previous machine. I used shims, which was horrible. So this is going to be a big improvement. POM reader. Oh, yes. Actually, I'm going to sketch it in the original sketch. So let's say that the programming pin is coming out 10 millimeters. So we offset this with 10. Because that's the surface of the programming drum. So let's just do this. And I'm gonna make the bottom perpendicular to the center of the circle. Boom. There we go.
Craig Wootune E-clip will be easier to install at that size. No need for snap ring pliers.
E-clip you can just push on, if I understand it correctly. So but if you have experience with E-clips, are they as trustworthy as a C-clip? No, as a circle. What was it called?
Circlip?
Circlip. Because that's my worry. Let's do 45. Let's do 20. And I think we should maybe have a fillet here between these. Say a 2 millimeter. I want to try to avoid to make this double-sided operation. So I'm only gonna add fillets on the front and leave the back like it is, I think.
Bit Fiddler, we use E-clip in our manufacturing all the time, no issues. Ty Tremblay, I find them more trustworthy. You can accidentally stretch a circlip on install and then it's loose.
This is my experience as well. Okay, very interesting. They also look chunkier, like if I saw it correctly.
Craig Wootune, used on many components on industrial machines. No real issues with reliability.
Okay, so Team E-clip was this happened yesterday as well.
Yeah.
The same thing. So I'm cutting the channel now in this POM part, and it has to be straight because of ease of machining. And it will feel like it can wiggle. And it can, but it will wiggle repeatedly. It will wiggle the same every time, which means that wiggle is really okay.
Wiggle, 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 wiggle. Woo!
Yes.
Team E-clip, hashtag, here we come.
Team E-clip is strong right now.
Slide diggity dog. Circlip for shafts that rotate, E-clip for stationary shafts. Okay.
Interesting.
Team E-clip, well.
Now I'm going to extrude the part that I can cut the channel last. I'm going to extrude the whole thing and then make a cut operation that feels more normal. So let's look at this from the front. So to this side, we're going to go out 6 millimeters, 8. And this is going to have, I think, a little bit irregularity because we have the hole on this side. So 15 perhaps. Should we just go up to this thing for, we go, oh, what happened here? Yeah. Okay.
E-clip of the heart. Matthias Pulse.
That's a good song, isn't it? Total eclipse of the heart. I guess that was a reference.
Yep.
Yeah, okay, good. I'm not always good with references, so I have Hannes 3000 have this reference aid upgrade. So you never feel left out when people are memeing. There was a problem combining... Oh, this is annoying.
Oh no, hashtag Team Paperclip is joining.
There's a famous thought experiment about AI that we ask the AI to make as many paperclips as it can. And it's so strong and so smart, so it just kills everyone and everything to get materials to make more paperclips. It's a pretty accurate description of where we're going, I think. Are you excited for the AI to arrive, Hannes?
It's already here. You're looking at him.
Well, if it's like this, I'm going to welcome it with open arms. All the drama out there, everyone. All this, what is it called? Catastrophizing.
Yeah.
It's all overblown.
Yeah.
It's cool. It's like this.
It's like this. How does it feel? You hang out with an AI and a wooden gear.
Yeah.
Those are your two best friends.
There's nothing more to it. Don't worry. It will sort itself out, apparently. Now I have this little plane, and now I'm going to cut this groove in the middle of this POM block. And we want a symmetrical operation, and we're going to do 420 to have a little wiggle room, and we're only going to cut the POM block and not the metal thing.
Oof.
Like
Oof.
this.
Oof. Oof.
Feels like engineering, doesn't it? But we are missing my... So if I did my work correctly, I want this a little bit lower. I should have this at a fingertip. I can lower this sketch line.
Thor Valar, make the metal part straight also.
100.
Mm-hmm.
So my idea is to keep... This is probably pretty like OCD-ish from me, but I want to keep the curve. I want this thing to be always perpendicular towards the programming pins, because I don't want the behavior to change, and I want it to always like the programming pin to hit it perpendicularly. That's why I want this little curve, but it's on such a mathematical level. So it's like, let's measure it. Maybe you're right. Maybe it should just be straight. Maybe I'm stupid here.
No,
I know, but you know what I mean. But thank you.
Jesper Klang, who needs friends when you have the extrude command? Truth.
Yeah. What can I say? I'm gonna make two parallel lines here, and we're gonna check the difference in how the programming pin will hit them, and then we're gonna find out how ridiculous it is to try to maintain the curve in the adjustment. So here in the beginning, it will hit it at this little angle. Let's actually calculate this angle. 3 degrees. Okay. So there will be a 3 degrees like difference. And over here, it should be kind of 3 degrees the other way. 1.5 degree. So depending on how long travel we want in the adjustment, this might be just total overkill from yours truly. Because the timing... What do you think, 3000?
I see some here. There's 2 camps here.
Yeah.
People are saying curved as well.
It's a nice feeling. The curve.
No, it should not be straight.
The curve is a nice feeling. It's a feeling that the reason I wanted is that I just want to delay the hit point. I do not want to change how the hit point is interacting with the programming pin. And it's on, I am pretty sure it doesn't make any difference, but theoretically it's the right thing to do. That's how I feel.
James. Martin, if the extrude from offset option changed your life, you should try from object. Just draw another sketch on the perpendicular plane and link all your extrudes to points on the sketch.
Can you read it again?
If the extrude from offset option changed your life, you should try from object. Just draw another sketch on the perpendicular plane and link all your extrudes to points on the sketch.
I didn't understand the last one, but the from object... I have to look into the from object.
Chris B says curved equals form, straight equals function.
I don't fully agree with that. Maybe in practice, you're right. Maybe in theory, I don't fully agree. I've lowered this thing. I think I'm going to lower it. Wait, I can have it down here. Why don't I have it here in the corner? Then this piece gets much smaller. Why do I have it up here? I'm stupid. No, I shouldn't say that.
No.
Shouldn't say that. I'm gonna say that you are here. Can I do that? No, I cannot. Why can't I then? This is an issue when using a lot of construction planes. When you made a plane from a sketch line, you really don't want to. You really don't want to change out the sketch line, and I'm gonna do that now, and that can mess up your sketch.
James has a follow-up here about the extrude command there.
Okay.
So the start point and end points on your extrudes are linked to point on a sketch. So you can edit the sketch and all your extrudes will update.
Also, to object is not only solid surfaces, to objects are also sketch points.
Well.
What? Oh my god, it's going to be a second marriage.
It's going to be a second
When you really love each other, you marry again.
Yeah.
People do that.
Yeah.
Why can't I end the extrude command? So this is what happened now. I'm just gonna fix this first, then I'm gonna investigate what was just stated there. So I have to reselect a new line here to base this plane on. And sometimes when you do that, things go wrong, and this time things went right. And obviously now we wanna remove this curve from this sketch. Is the humidifier out of water, Hannes?
Yes, I'm gonna refill that pretty soon because you know what? I've learned so much today, Martin.
Oh, is it that time already?
It's that time now.
Okay, I want to finish this, but I have still some work to do on this. So, okay, let me just say that I'm going to look into the extrude to sketch objects comment, and we've been talking with the Dragon today. We've been thinking really large about how big we should make this machine and what result that has on this programming wheel, all the orange lines here. And you've been very, very helpful, and it's been an honor to have your company. So let's see you in the next stream. Take care.